Good afternoon, everyone. Another beautiful day with chemistry. Couple of you are in like somewhere. Like until they get here, let's do this little part. I want you guys to check this. I guess couple of these I left as homework reactions. Just check this. The Hamian Pinnacle, you can get here. Like there are 2 rows here. Come. 2 empty rows. Get here. Are you okay with that? It is like feeling shy to get up or something. Okay, raise your hand if you couldn't get to the exam. If you couldn't get to the exam, yeah, only a couple. Okay, so I just want to talk about that exam. I know for some students, like exam is really difficult, but some are like I just asked you guys today. Like some are like they are okay. Some are like first paper is really good. Second paper you didn't have enough time. Is it difficult? The paper difficult. The second paper. Okay. Let's say if you only talk about whatever this Ratnapura city that you are writing for your real exam. So, like how many students are writing? Let's say almost like 2,000 students, but how many selecting? Only 100. If you work like normally, if you have work like generally, then you are getting a general or normal results. You can be 1 out of 1900. You cannot be 1 out of like final like 100 out of 2000. Okay, if you want to be extraordinary, you have to work extraordinary. If you want to win something that others cannot win, you have to push yourself and you have to work harder. Paper is not that difficult. I checked the paper. Only thing is, this is your very first experience, I guess. Is there anybody who done like 50 MCQs straight like in kind of an advanced level exam? Raise your hand. Yeah, this is the first time. But you know, for your final exam, you are getting this kind of exactly this format, 30 normal, 10 ABCD, and 10 two-statement questions. Now you know what kind of paper are coming to real exam. How you're going to choose questions. And I have given all instructions last week, I guess. So regardless your marks, I want you guys to get this experience, but I'm counting your marks on your term test. I have given this one to give you this practice, timing, hasty, whatever, like, you know, the silly mistakes, how you manage everything, how you will face this exam. So when it comes to the real term test, then you know how you're going to manage that. That is the target. That is my only target. So don't worry about even, no worries. But ඔයගොල්ලන්ගේ term test එකට බින්දුව ගත්තොත් නම් big problem එකක් වෙනවා. ඒ කියන්නේ like as an example, the last week I had this little discussion with this couple of these Visakians. I told you guys there are these 5 special girls coming to me, like our captains තියෙන set එකේ 5 දෙනෙක්. They missed in the part stuff. So now they are doing, some of them are doing really good job. Amazingly good job, magically good job. Then they are like, how would you assure that your position in the university is like already, how would you know that? There's a one single indicator. Let's say usually, so the Visakha is called like a medical factory, because usually each year like more than 50 50-ish students from only Visakha going to medical faculty. So then I was like, if you are in first for top 40 of your school, let's say from your school every year 10 students are going for medicine. Then if you are in that top 10 or top 5, top 6, then it is so much assured that you have a secured place in your faculty. You are supposed to have your own indicators. To do that, you have to work like really well and you have to face your term test really good. Otherwise, how would you find that? Then your question is secure, then your brain is happy, then you are not like always have this feeling like, you know, the nervousness that මට පුළුවන් වේද බැරි වේද like a 26 කට්ටියට ඔක්කොම වෙනවා කරන්ට් වදිනවා වගේ වෙනවලු gastric වැඩි වෙලා like අර nose එකේ hanky එකක් බැඳලා දියන්න වෙලා සමහර some students are continuously having runny nose. Why? Because they are stressed. Some are හැමදාම තිබිච්ච අය සමහර කාට stress වෙලා අර ඒ වගේ නැතිව නිදහසේ කරගෙන යන්න ඔය experience එක දුන්නේ. So I'm really glad like all of you participated. If you could not be able to participate, ask Manjula aunty the paper. I would post this marking scheme maybe tomorrow. I guess I would be able to post the marking scheme. And if you want to discuss the paper, so you can participate for this normal regular Monday class. Okay. So who couldn't come, just do the paper and hand it over to Manjula aunty, then I can ask them to check it. But your marks I cannot put into ranking because like you know the if you miss the paper. Anyway, so we are in this very comfortable situation of inorganic chemistry. This is little homework part that I ask you guys to check. How many are missing? I mean, couple of students are missing today. I asked you guys to get to the class physically because today we are doing like a part really challenging. That is the analytical chemistry part. You guys done here. Then I'm moving directly to this nomenclature part. Okay, so the very first part was this simple inorganic compound. First you are naming the cation and then the anion, and then you are keep a space between them. If you have one single oxidation number, you are not writing the oxidation number, you are giving the English name. If you have variable oxidation numbers, Latin name with us and it. Latin name with us and it. Just memorize with one single example that you already know, because here we are talking about the rules you already apply. You don't know those are the rules, but you know the names like ferrous ferric, lower us, highest egg. And simple anions, you are ending with ide like chloride, oxide and so on. And then oxo anions, lower ide, higher 8, lower ide, higher 8, but you are not mentioning oxidation numbers. When there are 4, you have only one single example, group 17, hypoiodide 8 per 8. If you go with bromine, you can say hypobromide, bromide, bromate per bromate. Those are the 4. When there are hydrogen, you mention hydrogen as bi. Okay, so we did couple of these examples at the class. Rest of everything, just check your answers here. Any question, anything? Rehan, you okay? If you've written with a pencil, you can just write with a pen now. If you're done with a pencil, just copy with a pen. Because some are writing, anyway, I'm waiting. Can you up here? If you come online now and if you still, I didn't send you guys the link, just ring me, okay? Shai was just waiting. I just saw that. Okay, all are here. All are here. Check answers. Let's say that all 15 were given as homework. Raise your hand if all are correct. Madi, good, very good, impressive, who done that? Like, එකක් දෙකක් වැඩි ආද විසඳ? ඇයි වැරදුනේ කියලා දන්නවද? Focusing, attention, නේද? ඒතර ඔයාලා හැදෙන්න ඕනේ. තව කොච්චරක් දිනවද ඔයාලට එක්සෑම් එකට? අවුරුද්දයි සති 22ක් තියෙනවා මේ වීක් එකට. අවුරුද්දයි සති 22ක් තියෙද්දි මම හැම වීක් එකකම ඔයාලට මතක් කරනවා. මම දන්නේ නැහැ once we done 26 exam මට ඔක මතක් වෙයිද කියලා කියන්න because they remind me. Ma'am, do you know how many weeks we have? කියලා ඒගොල්ලෝ මට හැමතිස්සෙම remind කරනවා. So ඔයගොල්ලන් තියෙනවා 1 year and 22 more weeks. එච්චර ගොඩ කාලයක් තියෙද්දි කියන්න මේ කාලේ ගොඩාක් දිග වෙන්නේ වැඩ කරන ළමයාට වැඩ කරන්නේ නැති ළමයාට ඒ බලලා මේ බලනකොට ඔක ගෙවිලි ඉවරයි. වැඩ කරන ළමයට very effectively you can do a lot. Because I want you guys to reach island ranking, having 300s for each of these subjects, 100 for each subject, okay? That is the target, not only for chemistry. I didn't leave any homework here. Hydro, whatever the name, ic acid, hydroic acid, and then the low oxidation number, it become us, it become ic. Sulfurous, sulfide becomes sulfurous, sulfate becomes sulfuric. So those are the rules for acids. And then simple covalent compounds. Again, so you are going with the first more electropositive, more electronegative was the second, and then the space between them, and more electronegative one end up with ide. More than one, you are naming as mono, di, tri, tetra, penta, hexa, but mono now comes to the front. And when you are having two of these vowels together, first vowel is cancelling off. 6-1 we did at the class. Okay. Check these answers. Okay, other 4. 5, 6, 7, 8. Give me which one, darling? Manada, which one? Fifth one. Dinitrogen tetroxide. Is it? Perune. N2O 7 කියලා දෙයක් දෙන්නේ. එහෙම compound එකක් තියෙන්න බෑ නේද? ඒක N2O4 කියලා හදාගන්න printing error. N2O3 ද තියන්නේ? එහෙනම් තියෙන්න පුළුවන්නේ. Trioxide කියලා දාගන්න. එහෙම දාවේ? answer එක. N2O3 dinitrogen trioxide. That's correct. Leave it. IPAC naming, we are dividing into two different parts, simple and complex. So these are the simple inorganic compounds. First cation and then anion. And then there is a space again. Single oxidation number, English name without indicating the oxidation number. Variable oxidation states, Latin name, English name with the oxidation number. English name with the oxidation number. Simple anions, NSI. Oxo anions, same 8, only 8 with the oxidation number. Hydrogen here this time named as hydrogen, not as bi. Hydrogen is as hydrogen. Okay, we did a couple at the class. Check answers. Raise your hand if you want, like, the first part again. This was covered, try hydrogen phosphate 5 here, make sure. Moving on. Make a oxide ne. Maybe like you didn't do exact rule for this one. Chloric oxidation number and 3 acid. Then chloric 1 acid, 3 acid, 5 acid and 7 acid. Other 3. Okay, so the part that you're going to gain this one of the marks of this 50 MCQs. Then you can 50 MCQs do ne baby units pahenne. Itanna koya 50 MCQs eddi syllabus එක cover වෙලා කොච්චර complicated questions එනවද කියලා. Just practice. Practice makes you perfect. Again, first cation and then anion. But remember, in the cation or anion side, one part is the complex. One part is a normal anion or cation, the other part is a complex. And again, there's a space in between. Coordinate sphere, positive or neutral, English name with the oxidation number. Positive or neutral, English name with the oxidation number. If the coordination sphere negative, Latin 8 and the oxidation number. Latin plus 8 and then you are writing the oxidation number. And then we're going to talk about the ligands, different ligands. Neutral ligands, they are giving a couple of these names you have to memorize. Plus you have to memorize what is the ligating atom. You're going to memorize the ligating atom as well. And if it is the anion, anionic ligand, you are ending as O, the word O. If it is the positive charge, you are ending it as EM, ammonium and so on. More than one ligand, di-tri-tetra, you are naming that way. More than different kinds of ligand, more than one kind of ligands, then you are giving names with the alphabetical order. That's all. Api, how many we did at the class? We did couple at the class. How many? 4. Time okay, let me go through this again. Okay, nicely, slowly. I know you guys would do a lot of mistakes and you don't know exactly the rule. So I'm going to go one by one very slowly here. Okay, so this is cobalt. I'm just writing its name. This is cobalt. I'm just writing its name. And then we have one of these ligand, NH3. NH3 name is amine. 6 mean the name we are using 6 same type of ammonia, that is hex. And then this oxidation number is plus here. If the oxidation number is plus, we are writing English name with the oxidation number. English name with the oxidation number plus we need something else, that is to find the oxidation number of this cobalt. This plus 2. This is a plus 2. Since this is 0, neutral molecule's oxidation number is 0. Oxidation number of neutral molecule is 0. So that this is 0. So that this plus 2 is supposed to coming from the cobalt. So that the oxidation number of cobalt is supposed to be plus 2. So when I'm naming them, first we have to write ligand. All the ligands first. I don't know, I make all the ligands first and then the metal. එතකොට ඔයගොල්ලෝ ligands ටිකක් ලියනවා, metal එක ලියනවා, ආයෙ ligands ටිකක් ලියනවා. එහෙම යන්න එපා. At the end you are writing the metal. First you are writing, let's say you have like 4 ligands, 5 ligands. Complete all the ligands. Then you are writing the metal. Remember that, okay? So since I have this has just one single ligand. How many? That is hex 6, okay? So I'm just writing that part first. I'm first writing the hexa first. And then the name of the ligand, that is amine, A-double-M, okay, amine. And then ligands done, I have the only one single metal, that is a cobalt, not 8. 8 comes with what? Latin 8 comes with negative complex. If the coordinate complex having the negative charge here, then we are going with cobaltate. But here it's positive, so it's just a metal, cobalt with the English name. And then the oxidation number. Here the oxidation number of cobalt is plus 2 here. And you're going to leave a space here, and then you are writing iron here. මේක හරි කට්ටිය අතුස්සලා ඉන්න ඔක්කොම කලින් tetrachloridocobaltate 2 space ion. Tetrachloridocobaltate 2 space ion. Well done. හරි අපි බලමු. Let's see. Don't worry. තව දෙක තුන ඊට පස්සේ ඔයගලන් හරියනවා. Okay, again I have the metal, but before I like cobalt nang either English name or Latin name, just one single. But I'm going to check whether which name I have to write. For that I have to check this charge here. That's negative charge, negative. So I'm going with 8. Cobalt, it's just the same. So I'm just writing cobalt here. The Latin or English, just the same cobalt. Then the ligand, this ligand is Cl minus. So the name is chlorido. But I have 4 of them. So that's become then tetra. Then 8 part comes because you have this negative ligand 8. 2 of them here, minus 2. For Cl minus mean minus 4. For Cl minus mean, that charge is minus 2 is here. For Cl minus is minus 4. To give minus 2 out, another minus 2 is supposed to be neutralized with plus 2 here. So that the oxidation number of cobalt here is plus 2. So this is a plus 2, minus 4 equals minus 2. So we figured out the oxidation number of the central metal. So we have all the resources, we can write the answer now. First ligand, and how many? We have 4. So it's tetra. Then we have the ligand chlorido. Then we have the metal cobalt. Then it's the corner sphere is negatively charged, so the 8 is negative. And then the oxidation number, that is plus 2, so 2. And then space, and then ion. Space, and then ion. Okay, I want you guys to check something. You start from here, all the way from this letter T, all the way from here to here, all the way from here to here. Can you see that there are spaces of your answer? Check your answer. There cannot have spaces. What is the space you can have? Only one single space. What is that? In between cation and anion, or in between this ion and here. Only here you have the space. Rest of everything you are writing as a one single word. All these are you are writing as a one single word. If you done mistake, just write there one single word. And I want you guys to check something else. And then check that whether there are any uppercase letters here. Uppercase letters, rather the first one. This one either uppercase or lowercase, okay. But if you have written uppercases in between, it's wrong, no marks, 0 marks. Make sure that there are no uppercase in between the name, other than the very first letter. Okay, copy this down. Can I move on, everyone? Hexaamine cobalt 2 space bromide. Hexaamine cobalt 2 space bromide. Raise your hand if this is correct. Yeah, maybe did you write like dimer or something? Don't do that. You don't want that, okay? Because if you go with this, because inside this bromide, when you write that, you know they are supposed to be 2, then only you are getting this oxidation number plus 2. So it implies on here that 2 bromine are there. If you go from this structure, that's the second part of this lesson. If you go this name to draw this structure, you draw 2 bromine. Then you don't have to mention here that. What else mistakes you guys were done? And then Br2. If this is just a Br2 molecule, what kind of a bond do they have in between them? Maximum they can do this coordinate bonding. Maximum if possible. So they cannot have, with Br2 they cannot have ionic bonding. We did that, you guys know, between the coordinate complex and whatever the other part. Either anion or cation, this is the ionic bonding. So these two supposed to be ions. So we are writing this Br2 as 2Br minus. So the name is bromide. So name is bromide, that is the anionic part. Then the central metal. If you have 2Br2 here, that is minus 2. So that's supposed to get this minus 2 charge. The charge is minus 2. If the charge of the anions are minus 2 is supposed to be neutralized with plus 2. So that the coordinate sphere is supposed to get plus 2 charge. Since ammonia is neutral, cobalt is supposed to get plus 2. And then this is cobalt, amine, hexamine 6, then bromide. So that the name become hexamine cobalt 2 space bromide. But when you are writing, make sure all the way from here to here one single word, no middle upper cases, and then space, and then one single word. Make sure all the rules are fulfilling. Okay, copy this. I'm really happy the way you guys are doing this class with me, but I want to make sure that you are doing everything nicely with all 3 subjects. And you know, always there are my assistants, they can support you with any problem with any subject. Make sure that you are going nicely with all 3. ඔයගොල්ලන්ගේ paper class එක අරහම එක කතා කරා. Yeah, I have this special notice 14th කොහෙදනේ 14th Saturday ද වෙන්නේ 13th මගේ big seminar එක. ඔයගොල්ලන් එනවද මගේ big seminar එකට මට support කරන්න? Yeah, 13th Friday is my 2028 big seminar. Then the Saturday. Then this next coming Saturday, I don't remember his morning, is having this Arhamaya's paper class or theory class or whatsoever he is planning stuff. I don't know exactly the time. Sir, maybe Manjula auntie knows. Or I'll write to the group. ඒවා මට නෑ මම ඔයගලගෙන් අහලා එයාට කතා කරගත්තා. He is real busy, you guys know, but වද දීලා පටන් ගමු නැත්තම් කෙරෙන්නේ නැහනේ කියලා දාගත්ත ක්ලාස් එක. Finish, moving on. Then K2 potassium K2 කියන්නේ potassium gas නෙවෙයිනේ. ඒතර අතර Br2 gas නෙවෙයි කියලා you have to just get the same instincts. So K2 is not gas. This is just a potassium. This is just K plus. K plus group 1 they never make covalent bonding. K plus 2 of them are here. So the name become potassium tetrachloridocobaltate 2. Potassium space tetrachlorido. Raise your hand if this is correct. Madhyane. I want all hands to raise. මොකද එක්කෙනෙක්ට වැරදුනා වැරදිච්ච එකකට ලකුණු නැහැ. ඔන්න චුට්ටක් තත්පරයක් මේ තත්පරයක් බලන්න මගේ සුදු මූණ දිහා. සුදු මගේ සුදු මූණ දිහා තත්පරයක් බලන්න. මේකෙන් nomenclature එකෙන් හැමදාම ඔයාලට දැන් මේකේ වෙලා අපි organic පටන් ගත්තාම right after we start organic we have nomenclature. අර ඒක end එකේ නෙවෙයි note එකේ. That's really fun. ඔයගලන්ට හොඳටම ඔළුවට යනවා ඕගොල්ලන් තමන්ගේ self එක focus තියෙන කෙනෙක්ද නැති කෙනෙක්ද කියලා. Silly mistakes කරනවද නැති කියලා just identify yourself. Just through your own mistakes, identify yourself. Then only you can improve. Okay. So make it if I go with one by one. Make it දැන් මෙතන K2 නේ. එතන මෙතන තියෙනවා +2. Then the coordinate complex supposed to be -2. Another signal gets there. 8. Then the Latin 8. But still cobalt is same cobalt. So just the same cobalt but going with 8. But before that I'm writing these ligands. I have Cl minus but 4 of them. So that I'm going with tetrachlorido. But this part is negative part. This is the negative part. So this is anion. So first I had to write cation. Cation is a potassium. So this is cation. This is a plus side. And then there's supposed to be a space between that. Only the focus. If you focus really well, 100 marks is there in marker. Isn't it? Finish everyone? Can I move on? Moving on. Raise your hand otherwise. If you're not done, raise your hand. Tetraamine diaqua copper 2 space nitrate. Tetra. Okay, let me repeat this nicely and slowly. Tetraamine diaqua copper 2 space nitrate. Raise your hand. Ha! Getting better. Like that. Nitrate, nitrate, nitrite, just use that nitrite. That's how they are doing for the exam. It's really okay. Okay, 2NO3 minus. Then you have -2 here. To neutralize that, coordinates we are supposed to get +2. So to neutralize this -2, you're getting +2 here. Then the whatever this coming with the English name with the oxidation number, so that's copper. And then how do you find the oxidation number? Ammonia is 0, water aqua is 0. So this +2 directly coming from copper. So the oxidation number of copper is +2. And then I'm going with these ligands. I have NH3 that is amine and H2O that's aqua. I cannot go with A because both have same A. I'm gonna go with the second letter that is M and Q. Alphabetical order එක මතක නැති අයට ඒකත් ඉර තියෙනවා කොහොමද වෙනවා. Like knowing exactly real thing is then you are swapping these ligands. Don't do that. Such silly mistakes. So that M comes first. So I'm writing amine first. Then here you have 4, that is tetra. Here you have 2, that is di. So that the name goes with, first I'm writing, the first one is this one, tetraamine, and then this one, diaqua, and then this one, copper, oxidation number, then space, then nitrate. Can I move on? මේක අවදි කියන්නේ. ඔන්න දැන් තමයි real exam questions ඔයගොල්ලන්ට check වෙන්නේ. Try amine di aqua chlorido cobalt 2 space. This is nitrite. Because here NO2 minus is nitrite, minus 1 charge. So the coordinates here get plus 1, plus 1. Then what is the charge of the cobalt? Because here you are getting 0, 0 and minus 1. Plus 1 is outside. So that minus 1 supposed to be neutralized with another plus 1. So that cobalt is supposed to get plus 2. So the plus 2 minus 1, only plus 1 goes out. Plus 1 goes out. When you are writing that, you are writing 1 plus 1 plus, okay? 1 plus. Numerator comes first. Okay, that's sorted out. So that the coordinates here is positive. So the no 8, we can just write cobalt 2. Then I'm going with the alphabetical order. I have C here, amine here AM, aqua AQ. Amine comes first, AM, then AQ, and then C. And then write the number of these ligands, number of ligands. Manjula? Manjula, මට water පුත් ඕනේ. Temperature කීයද තියෙන්නේ? පච්චට කඩ ගන්න. කොරම 20 වලට විතර දාන්න. ඔයගොල්ලෝ සීතල නැහැ නේද? මේ මට ස්වෙටි. මේක හරි කට්ටිය raise your hand. මදි. Silly mistakes නැතු යා. අජිත් ආව දාලා ගියාද? සර් ගියාද? Seriously. හරි. Number 7. Number 7. මට mistakes එපා. Number 7 කරන්න. දැන් මේ අත්මදිනේ number 6 වල අත්මදි. Number 7 recheck. Recheck the number 7. ඒක නම් ලෙස එක. Number 7 නම් ලෙස එක. But recheck it. Done. ආවද? Hexa aqua vanadium 3 space ion. Hexa aqua vanadium 3 space ion. Raise your hand if this is correct. ඒක නම් හරිනේ. But only 17. Moving on. Hexa aqua vanadium 3 space ion. Koyama. Shall we missing it? Okay. This one. Tetrachlorido titanium 4. Make a neutral. So you cannot say ion. This is neutral. So coordinate complex has this 0 oxidation number, 0 charge here. So that's Cl, 4Cl minus neutralized with 4 pluses. So the oxidation number of titanium is plus 4. So it's 4. Raise your hand if this is correct. Okay. Just check next one while if you done this one, just try to check the next one, because since you guys get better idea today, now like if you have any mistakes, you can find it out. Check whether you have done silly mistakes here. I'll read it for you. Tetra, amine, aqua, chlorido, chromium 3 space chloride. Raise your hand if this is correct. Alright, at adui. Aye. මේ දෙක තුනක් කරනකොට ඒ alphabetical word එක පාඩම් කරන්න දෙක එදලා කියලා. Just memorize back the alphabetical order. Okay, Cl minus 2, then plus 2 here. You have minus 1 here. So that to get plus 2 out, chromium is supposed to have plus 3. Then you have aqua, amine, and chlorido, 4 of amine, tetra. Next one, moving on. Okay, number 10. Tetrachlorido manganate 2 space ion. Raise your hand. Well done, well done. Yeah, now you guys are there. Menudi, what are you guys doing at school now? School? Oh. Apa dah bisa ni? Oh, really? Analytical part? Oh. So the nomenclature done? Then you're going to have a hard time at school. Just hang it. Finish. Moving on. Okay, number 11. Number 11. Hydroxido iron 3. Again, there is no charge shown here, no anion, no cation, so it simply means here charge is 0. And then this is aqua 0. This is, you are not showing the charge here, but you're supposed to know this is 3 OH minuses. Then to get the neutralized 0 outside, this is supposed to be neutralized with 3 of the plus charges. So the oxidation number of this is plus. Neutral or positive, we are going with the normal English name with the oxidation number, so it's iron, hydroxido and aqua. So aqua comes first. Inorganic book එකේ ඉවරයි නේද? ඔය ටික චුට්ටෙන් ඉවර වෙනවා. ඔය ටික ලියන්න නෑ මොකවත්. නිකන් මට කියවන්න විතරයි තියෙන්නේ. ඇනලිටිකල් පාර්ට් එකේ උනා. Done. Moving on. Number 12. Penta aqua nitrosyl iron 2 space ion. And then oxidation number, this is +2 here, 0 here, 0 here, +2 belongs to iron then. So the coordinates here is plus. So the English name with the oxidation number. English name with the oxidation number. Penta-aqua nitrosyl iron, 2 space ion. In case if you get any sort of extra date, just remind me, okay? බලන්න මේකේ තායි මිස්ටේක් කරලා කරගෙන තියනවාද කියලා දෙක තුනක් දුන්නොත් හරි හරිද? ටෙට්‍රා amine di chlorido cobalt 3 space nitrite. Are you guys really okay? You guys don't want my support? -1, so that the coordinates here become +1. This is anion -1 nitride, so the coordinates here is +1. But 2Cl minus chlorido -2. So to get the +1 out, since ammonia is 0, copper is supposed to have +3. So this is +3. And it's a positive coordinate sphere. So this is going to be the English name. So this becomes this cobalt, amine, tetrachlorido. And 2 mean di. I guess දැන් ඇති නේද ඔයගලන්ට? දැන් ඇති නේද? I guess you guys are perfectly saturated with nomenclature of coordinate complexes. Okay. 14th one. Sodium space tetra cyanido nickelate 2. Because the coordinate sphere is with 2 pluses, 2 sodium, this is become -2, so that 8 gets there, 8. And then just the nickel is always nickel, but here nickel become nickelate. Rest of the part you guys know. Then the cation is sodium, so you are just writing here, Na2 become sodium here. Cyanido. Once we have the full knowledge, inorganic answers are really straightforward, but getting the full knowledge is the most challenging part with the analytical and with the full memory of this SPD. Until you get there, you feel really frustrating like unit 3. But once you start, get the practice, once you start like you know how to do inorganic become really easier. That's the secret of, that's the magic of inorganic. Then whatever the way they are tailoring made these questions, you guys can do them. Moving on. Hexa, aqua, copper, 2, space, sulfate. Only 2 more. Number 16. Tetraamine zinc 2 space nitrate. Raise your hand if this is correct. Okay. Minus 2. This is 0. So this is become plus 2. NO3 mean NO3 minus. Next one. Hey, ma'am, rap artificial. Yeah, like there are real compounds. So these are existing real compounds, but such compounds cannot exist. Like coordinate number maha 500ක් දාන්න බෑනේ එක metal එකකට. But artificially you can make like the yeah. Moving on. ඇති නේද? 4. Pentaamine carbonyl copper 1 space chloride. Correct. Well done. Well done. Hurry. May 17. Method, even here it's okay. Ahead of you, if you guys made your mistakes, that's okay. May 17 17 හරිය අදුසන්. Well done. May not. Asha, very good. එකක් වැරදි කට්ටිය. එකක් නෙවෙයි දෙකක්, එකක් දෙකක් තුනක් වගේ වැරදිලා ඒක ටිකක් හරියයි. හා. එක්සෑම් එකට 2000ක් ලියුවාම මෙඩිසින් යන කට්ටිය අදුසන්. නෑ, මෙඩිසින් හරි ඉන්ජිනියරින් හරි යන කට්ටිය අදුසන්. අදුසන් ඉතින්. කෙමිස්ට්‍රි වල ලකුණු 100ක් ගන්න අය අදුසන්. ඔන්න 100ක් කියන්නේ අර hypothetically like 99 point something ganna hai dosan. Hi. Finish, I guess. IUPAC නාමය දී ඇති සංගත සංකීර්ණ සූත්‍රය ලිවීම. සිංහල වචනේ හරි පොඩි hina වෙනා නම් ඕගොල්ලෝ සිංහලද? ඔයගොල්ලෝ සිංහලද? But සමහරක් අචරණ hina වෙනවා තමයි නේද? Okay, first cation and then anion, no space. Coordinate complex is in between a box bracket or square bracket. Sphere, first write the metal and then ligands. Multi-atomic ligands within parentheses. Coordinate number, you're supposed to show this how many ligands. If I say a different ligands, consider the alphabetical order of ligating or donor atom. Remember that, ligating atom. And for, if the complex sphere is charge 1, right side top, first we are writing the numerical value and then the charge. Make it the first one. Sorry. Make already දුන්නද මම? නෑනේ නේද? Sorry. මම දීලා කියලා I was just trying to check this homework. එහෙනම් එන්න මනසිහියට එන්න. මනසිහියෙන් මේකත් අහගන්න. mistakes නැතුව මේ ටිකත් කරන්න. ඔයගොල්ලන් මේ ලස්සනට දැන් ලස්සනට ඔයගොල්ලන් ඉගෙන ගන්නවනේ. ඔය ලස්සනට ඉගෙන ගන්න එක අමතක වෙන්න අරින්න එපා. එකම රික්වෙස්ට් එක ඒකයි. ඔයගොල්ලෝ හොඳට කරනවා. ඔයගොල්ලන් අර මැජිකල් ගෲප් එකක් but මම හැමදාම worry වෙන්නේ කාලයක් ගියාට පස්සේ ඔයගොල්ලෝ give up කරනවා. ඒතර කට්ටියක් විතරක් හැමදාම හොඳට ලස්සන happy faces එක්ක එනවා. අනිත් කට්ටිය ගෙවල් ඇස්සේ මුල්ලක හැංගිලා අඬ ඉන්නවා. ඒ ගානට ඔයාලට වැටෙන්න බෑ. හරි. එන්න. So this time they were given the iPad name and we're going to draw the formula. You're going to draw the formula. So ඔන්න මම formula එකක් ගන්නවා example එකක්. Let's say sodium chloride. අපි ඉස්සෙල්ලා මොකද්ද formula කියලා ලියන්නේ? write the cation. First we are writing the cation, that is sodium, and then the anion chloride followed by the anion. The sort of same rule. And method space there are no space in between sodium and chloride. That is the second rule. No space. No space. First cation, then anion, the rule number 1. No space is the rule number 2. And then the third one, you guys know the third rule. Always we are writing the coordinate complex within square bracket or the box bracket. Make us coordinates. So that is the third rule. See, you guys know already this. And then, what would you write the first? First you are writing the metal and then ligands. Iselama complex sphere. Okay? First you are writing the metal, then you are writing all the ligands. And then we are moving to ligands. Multi-atomic ligands, like examples. Multi-atomic ligands like NH3, H2O, such ligands, NOCO. So you are going with parentheses. You have to show parentheses for multi-atomic ligands when you are having more than one atom. Cl වලට මොකද කරන්නේ? මෙතන atom කීයක් තියෙනවද? එකයිනේ, not number of letters. They are talking about number of atoms. Cl එකට parentheses දාන්නේ නැහැ. This is one single atom, understood? Dana is CO Dana, carbon and oxygen. So that you are going with the parenthesis, and then down here you are writing how many of the ligands. Different ligands. Remember this one. When there are different ligands, as an example, let's say you have NH3 and H2O. Consider the alphabetical order of, remember this one, ligating atom. ඔන්න මේ part එක ඔයගලන්ට චුට්ටක් වෙලා ගියාම අමතක වෙනවා. අමතක වෙන part එක මම වැඩියෙන් කිව්වත් ඇයි අමතක කරගන්නේ? මම කියන්න කලින් මේ බලලා ඉන්නවා. කරන්න කලින් mistakes කරන්න කලින්. Okay, what is the ligating atom of ammonia? The atom which is making dative bonding. What is the atom? Nitrogen. Nitrogen. Okay, so how would you write nitrogen? N-I-T-R-O, nitrogen. What's the ligating atom of this aqua molecule? That is oxygen. So that we are writing O-X-Y-G-E-N. So අපිට letters දෙකක් තියෙනවා. Now we have N here and O here. ඔය කෙනාද ඉස්සෙල්ලා ලියන්නේ? aqua නෙවෙයි. Nitrogen. Understood? Then comes oxygen. Alphabetical order of ligating or donor atom. Understood? Ligating or donor atom. ඊට පස්සේ කවුරු එකක් මෙතන එකක් මිස් වුණානේ. මෙතන මේක මිස් වුණා මේ. තව චූටි එකක් මම මෙතන මිස් වෙච්ච point එකක්. Multi-atomic ligands, you are writing within parentheses. We talked about that NH3, H2O. But that's again, you have to write the ligating atom first. So what's the ligating atom of ammonia? What is the ligating atom of ammonia? That's nitrogen. So we write it as NH3. What's the ligating atom of H2O? Oxygen. Oxygen. Remember, so we write oxygen as OH2. Leonardo. This is the ligating atom. They can give the way like H2O, OH2, that's okay. Because for the last questions, they were never given us like OH2, they given H2O. We know OH2, H2, same aqua, but when you are writing the formula, you have to write the ligating atom first. No matter whether they know. Okay, that is that rule. It passes the last rule. When there is a charge, you can write the charge here, left top. First we are writing the numerical value. Whatever the numerical value you are writing first, then the charge. Let's say we are writing +2, then you have to write 2 plus. -3, then you are writing 3 minus. First the numerical value and then the charge. Read. Okay, topic. Writing. Okay, repeat. Writing the formula of coordinate complex when IUPAC name given. Number 1, write the cation followed by anion. No space between two ions. The complex sphere always written within square brackets. Number 4, in the sphere, first write the metal followed by ligands. Number 5. Multi-atomic ligands are written in parentheses. First write the ligating atom. First write the ligating atom කියලා highlight කරගන්න. ඕකනේ ඔයගොල්ලන්ට මිස් වෙන එක තමයි. You are first writing the ligating atom. First write the ligating atom. Okay, let's repeat again. Here, look at this straight. First, write the ligating atom which participate coordinate bonding. The number of each ligand should be, should be indicated in Arabic numerals as a subscript on the right side. Number 7. When there are different ligands, the alphabetical order of ligating or donator. Alphabetical order of ligating or donator. Highlight. Alphabetical order of ligating or donator. Alphabetical order of ligating or donator. Sorry. Okay, last one. Okay, let's read again. Number 8. If the complex sphere is a charged one, indicate the charge outside the square bracket as a superscript on right side. First, write the numerical value followed by the sign. Okay, filter ගන්න දෙයක් තියලා නැහැ. Okay, let's go one by one. Okay, look at the screen. හොයාගෙන යනවා. මේක ලේසි. කලින් පාඩේකට වැඩිය this is easier. What's the meaning of penta? Penta mean 5. Cyanido mean Cn minus. And here I'm underlining the ligating atom at the same time. Look at the screen. Look at the screen. There are like a lot of you can do together. You can do separately. Let's do this one together. Get focus really well. Get the full knowledge. Then you can go on with yourself separately. Nitrosyl, just NO. Again, I'm underlining this ligating atom. And then fermine, iron. What's the meaning of 8? Coordinate complex. Once you're done, supposed to have a negative charge. What is this 2? 2 means the oxidation number of iron, that is Fe2+. Fe2+. Okay, so මම දැන් නිකමට හිතලා first I had to write the metal, so I'm just writing ferrous. And then I have first cyanide, and then 5 times of that. Nitrosyl means nitric oxide, NO. Parenthesis, just 1, but I don't write that. ඊට පස්සේ එලියට එච්චරයි තියෙන්නේ. එලියට මට දාන්න ඕනේ you have plus 2 here minus 5 here. See, plus 2 here minus 5 here. Remaining it is minus 3. That's supposed to be the coordinate spheres number. So that I'm first writing the numerical value and then the charge. Numerical value and then the charge. I'm not done. I'm going to check whether this alphabetical order is okay. So that I'm going to check this carbon here and this nitrogen here. So the cyanide comes first and then nitrosyl comes. So it's completed. It's completed. So that this is the answer. Are you guys okay here? Okay. Copy this one. Copy everything here. And now then by yourself do the second one. Copy this one and then do the second one. Check your answer. Raise your hand if this is correct. Good, good, but not all. Group එකක් විදියට යන්න. You all have to do the like 5 amine NH3, chlorido Cl minus, cobalt CO, 3 mean cobalt plus 3, and then 1 negative chlorine, 1 negative, so it's minus 1, cobalt plus 3, So that the coordinates we are supposed to have plus 2, then but still you are writing as 2 plus. You are writing as 2 plus. Copy this one and then do the next one. Okay, third one. Raise your hand if this is correct. My boys are then focus nothing. Tetra, that is 4. Aqua, H2O. But I'm writing OH2 and the ligating atom is oxygen. Diamine 2, chloride of Cl minus, chromium Cr, 3 means Cr plus 3. Space here and then you have chloride. How many chloride? How would you find that? How many chloride? For that you have dichlorido here. So that is minus 2. And the oxidation number of chromium is plus 3 here. So that the remaining is minus 1. So you're supposed to have only one single chlorine here. That's how you are getting one single chlorine. Because here the charge is plus 1. Here the charge is plus 1. To neutralize that you can have only one single chloride. And then you are writing this is as OH2. Because the ligating atom is oxygen. Enough. Let's do the rest for homework for next week. Copy this one and let's move on to the analytical part. Okay, once you start this analytical part, the very first part is easy. It's not analytical, everything is difficult. Moving on. Analytical chemistry. Just day by day, you're going to pass until your exam. All of a sudden, we are at the analytical chemistry. I was keep saying, inorganic is easy. The most challenging part is the analytical chemistry. At the end of the day, now we are here. Not all the analytical chemistry is difficult. Shush. Stop talking while I'm talking. Okay, analytical chemistry is difficult because a little part is difficult, not everything is difficult. I'll just ask you guys to focus more for the part we are going with the difficulty. Analyzing means we are analyzing how much and what is consisting. To talk about how much, that is called the quantity. How much quantity is existing and what are existing, that is called the quality. So we are checking both quantity and quality. That is the part that we are moving with the analytical chemistry part. This is the chemistry involving in determining the elements, ions or compounds in a given sample. Quantitative mean determine the presence. Qualitative. Quantitative mean determine the measurement of either color, either mass, either turbidity, either presentation height, whatsoever. We are determining how much is there. Most important part is the qualitative part. Quantitative part we did couple of qualitative part we did already. Quality or whether it's present or not. Give me one example. Qualitative analysis. Quality mean whether it's present or not. we did couple of qualitative examples. What are those? One is the flame test. We can do the flame test to get to know whether it's present or not. Another something is color of these complexes. Complex color, can we say by that like how much is presenting? No. But knowing the color, we can say exactly these elements are presenting. So that's again the qualitative, about talking about the quality. So the first part is easy. But here I'm going with the second part, that is a quantitative analysis. We are dividing into 3 different parts: gravimetry, titimetry and jobs plot. Gravimetry, titimetry, jobs plot. Out of that, titimetric part is the most challenging part. Inside the titimetry, couple of titrations, couple of titrations are the most difficult part. So that is the part you have to focus really well. What's the meaning of gravimetry? Gravimetry means you measure some sort of a mass. To measure mass, what's supposed to be there? Which mass we are usually measuring? Solid mass. What's supposed to be there then? Some sort of a precipitate. So unknown something, we convert into a precipitate. Then we filter. We separate the solid part. We dry it. We measure its mass. That is the gravimetric part. Once you know the mass, how would you find the number of moles? Mass divide molar mass is the number of moles. Once you know the number of moles, how would you find the concentration? Number of moles divide volume is the concentration. That's how analytical chemistry is relating to unit 3. So that is one of the reasons analytical chemistry is little difficult, little like challenging. But when you are doing like finding those, you need this, let's say you know known something, then you are trying to find the concentration of unknown, then you need equation between known one and unknown one. Then unit 1 indala unit 18 වෙනකන් ඊට පස්සේ sorry group 1 ඉඳලා group 18 වෙනකන් ඊට පස්සේ D block එකේ ඉඳලා ඒ තියෙන equations ඔක්කොම අපිට ඕන වෙන්නේ ඔන්න උතනදී ඔන්න ඔය නිසා තමයි analytical chemistry become really challenging. ඊට පස්සේ ඒගොල්ලෝ මොකද කරන්නේ? ඔයගොල්ලන්ට most difficult unit is equilibrium. They are merging this analytical chemistry part with equilibrium. ඉවරයි නේද කතා කරලා? හරිද? ඉවරයි. Seriously guys. So then only this like equilibrium become most challenging because it is merging with unit 3 analytical chemistry plus equilibrium. So that just the very first day we started in unit 3, I told you guys unit 3 itself is important. Unit 3 is more important for analytical chemistry. Unit 3 plus analytical chemistry is most important part is these two together you guys need for equilibrium. Without equilibrium, reaching A pass, just reaching A pass is like impossible. Equilibrium is the most brainier unit. So you guys, I'm preparing you guys to get there through this unit 3 and analytical part. Okay, so when it comes to the harder like challenging part, I would ask you guys to be more focusing. Okay, let's read together. Analytical chemistry. Let's read. This is the chemistry involved in determination of elements, ions or compounds in a given sample. Basically, this can be divided into 2. Number 1, qualitative analysis, determination of presence of elements or compound, whether it is existing or not is qualitative. Number 2, quantitative analysis, determination of measurement of elements, ions or compound. මේක අස්ස තමයි අපි පොඩ්ඩක් අමාරුවෙන් ඉගෙන වෙන part එක. මේ part එක දාගන්න. If there are spaces to skip that part. Determination of presence of elements, determination of measurement of elements. Okay, so Quantitative analysis, we divide into 3 different parts. Gravimetry, titometry, job plot. Job plot mean like if I give you guys a little like idea, so you have, let's say, a compound series. That part of coming with the potassium permanganate, what's the color? That is pink. Let's say we need to identify another potassium permanganate which we don't know the concentration. Then we make colors, what are numbers? 1, 2, 3, 4, 5, 6. We know the concentration of these. And let's say this unknown concentration is exactly same as the concentration of the fourth one. Then what can we say? They both have same amount of potassium permanganate if the volume is constant. Clear? Likewise, this kind of a concentration series we are using in this jobs plot. Okay, so the first part is gravimetry, and then the titometry, and then the jobs plot. Under that, the very first part is the gravimetry. Sample is precipitated quantitatively. We know the quantity. And the dry mass of precipitate is used in calculation. Then another precipitation table, that's again important. Like you should know which compounds are giving these better precipitates. Water insoluble, heavy precipitates. We only can use such precipitates. Apne pulon the transient precipitates like partially soluble or maybe gelatinous. We cannot use such precipitates. We are supposed to have solid, fine, heavy precipitates to go with gravimetric analysis. So that I have taken, this example I have taken is to find the concentration of SO4 minus. We need to find some sort of a cation which is giving the exact solid clear precipitation with sulfates. Those are group 2 sulfates. Out of that I have decided to go with barium. Then I have to go with this barium something, the other anion of barium which is supposed to be aqueous. And then again we know all group 17 elements with group 1 and 2 anion cation. These halides are water soluble. So either you can use barium nitrate as well, because you guys know all the nitrates are water soluble. This is how they are deciding an experiment. So that I am using the barium chloride here. What would I do? Because I told you guys. So first we find the concentration. Let me check. So this important message. Not from you guys. Colombo chemistry. Okay. So first we find this mass of the precipitate. If you know the mass, then from this mass, what would you find? Mama. Number of moles. How would you find number of moles from mass? Mass divided by molar mass is the number of moles. Once you know the number of moles, what would you find? Concentration. How do you find that? Number of moles divided by volume. So that when we are planning this experiment, we should know how much volume of the initial sample is using. So some sort of a sulfate solution we are using, but at the end of the day we want the concentration of this sulfate, so that we need the initial volume. Once you find the number of moles divided by volume is the concentration. So that we need the initial volume. So we are getting known amount of, take a known volume of this given sample. Sample has SO4 minus. Okay, then we are adding barium chloride to that. How much barium chloride? How would you know that? Usually it's supposed to be in excess. Why we are adding in excess? Always we are adding in excess. May make keywords sort of in the final exam again. In excess. Barium chloride, why is that? What's supposed to be the limiting factor? When we're trying to find the concentration. We need to make sure all the sulfates are precipitating. To make sure that we are adding excess barium chloride. Excess barium chloride will remain in the aqueous layer. All the sulfates precipitate as barium sulfate. So the solid part consists all the sulfates. Clear that? So that we have to add excess. We have to add excess barium chloride. And then to that we are adding diluted nitric acid. Why is that? Okay, that is where this real analytical part and this inorganic chemistry is playing roles. This part is not that fully understood so far. We're going to go with the last couple of these 20 anions and 12 cations. 20 cations and 12 anions, that part. Once you completed that part, you're going to get the full knowledge here. In there, this little knowledge is there. barium sulfate. Barium sulfate does not dissolve in nitric, but all the other precipitates are dissolving in nitric. So to make sure only the sulfate is precipitating here. As an example, which other anions can make precipitates with barium? Precipitation table. Go on and tell me. Which other compounds, which other anions can give precipitates with barium? Again, what's the page number? Somebody, what's the page number? Precipitation table. What's the page number? Gizma. 47. 47. Page number 47. දැන් මට කියන්න කොච්චර examples ගන්න පුළුවන්ද ඔයගලන්ට මොනවාද? Barium එක precipitation සර කට්ටිය කියන්න. Phosphates precipitate ද? වෙන මොනවාද? Chromate, dichromate තියනවාද? Oxalate තියනවාද? මොනවාද phosphate එක දැන් precipitates? අමාය කිය මොනවාද? Barium එක දැන් precipitates මට ඕනි. Barium එක sulfate precipitate කියලා ඕකෙන් හොයාගන්න පුළුවන් වෙන මොනවාද? සනාදි. වෙන මොනවද කියන්නේ? Barium carbonate. Carbonate is also precipitate. Understood? That there are a lot of different precipitates. So that to avoid, come back to the order. Okay, to avoid all the other precipitations, we are adding nitric acid. Avoid precipitation of any other because we know we need to find only this sulfate. Okay, then what happen is filter. What are we filtering? We are filtering the barium sulfate. And then dry to remove water and to get the constant mass. Continue drying, weighing until constant mass. Why is the mass supposed to be constant? Then we can make sure that there are no water, only barium sulfate is presenting. Okay, see the very first equation, then this is the equation. Barium chloride with sulfate produces only the precipitation is a barium sulfate and then Cl minus staying in the aqueous medium. On the calculation part, totally 100% unit 3. So they were given, let's say the mass of the precipitation is M1, what is the concentration? Then how would you do that? Mass divide molar mass is the number of moles. So that we need the molar mass. So you're going to find the molar mass of barium sulfate. That is 233. That's again unit 3. We found all those different molar masses. So that mass M1 divide by the molar mass 233. Mass divided by molar mass is the number of moles. And that is this part. That is what number of moles. That is a barium sulfate number of moles. In barium sulfate number of moles, only part is sulfates, but barium sulfate to sulfate. Here you have one here. 1:1 ratio here, so that the same barium sulfate number of moles equals to same sulfate number of moles. Marking scheme steps to get marks. Okay, so that again the next step we say barium sulfate and sulfate are exactly same. So the number of moles of barium sulfate equals number of moles of sulfates. See the same M1 divide 233, M1 divide 233. We have now the number of moles of sulfates, If we have the number of moles of sulfate, that divided by volume is the concentration. So that is the next step. So this is the number of moles of sulfate. Number of moles of sulfate is this. And if we divide that by the volume, but usually we measure volume with the cubic centimeter. To convert this into cubic decimeter, we have to multiply with either, see the 10 to the power 3, 1 per cubic centimeter equals 10 to the power 3 per cubic decimeter. So multiply with 1000. So that is the moles per cubic decimeter concentration of SO42 minus. Leonardo. What is the very first step we do here? So they were given us this unknown sulfate solution. What's the very first step? We measure the exact volume. To that we are adding number 1, barium chloride. How much? Excess barium chloride. And then we are adding nitric. Why? Excess adding to make sure all sulfates are precipitating. We are adding nitric to make sure that no other precipitations are there. And then filter and then dry until you get constant mass. Once you get the mass, knowing this one, you have to write and you have to show this equation as well. The equation between sulfate and this barium chloride, so that we are getting barium sulfate. And then the next step, once you know the mass, that mass divided by the molar mass is the number of moles. So that what is the next step? Finding the molar mass of barium sulfate. Then mass divided molar mass is the number of moles of barium sulfate. That's supposed to be equal to the Chantusa number of moles of SO4 2 minus. Exactly same. That number of moles divided by volume is the concentration. Clear that? Okay. Let's read this. මේ පාටික අපි කියවද නෑ මෙතන ඉඳන් කියවන්න මාත් එක්කම quantitative analysis. What are the three different methods? Gravimetry, titiometry, jobs plot. Gravimetry, titiometry, jobs plot. So the first method is the gravimetry. Sample is precipitated quantitatively and dry mass of precipitate is used in calculations. Determination of SO4 2 minus, determination of sulfate ion concentration in a given solution. Take a non-volume. See, I have taken volume in cubic centimeters. That's why we have to multiply by 1000. Again, take a non-volume from the sample and add excess barium chloride solution and dilute nitric acid. Filter the precipitate and let it dry and get the mass. Continue drying and weighing until a constant mass obtained. Calculation part එක. Mass of precipitate ගන්න M1 කියලා. Then molar mass of the barium sulfate, it's 233. Mass divided by molar mass is the number of moles. And that barium sulfate number of moles equals to the number of moles of sulfate. That number of moles divided here by the volume is the concentration. මේ පාට එකක් කියලාම ෆිட் කරමු. Okay. Barium chloride solution should be added in excess to precipitate all SO4 2 minus. If the sample consists, මේ තියෙන්නේ අර barium එක precipitate වෙන්න පුළුවන් other anions, carbonates, phosphates or sulfides. These ions also can precipitate as barium 2 plus source. This can be prevented by adding dilyl nitric acid to get dissolve these. Okay. Complete from here. Make it 3 subtopics. You're going to write these 3 subtopics. 3 subtopics just mention here. The space is there. Gravimetry, titiometry, job plot or jobs plot. show the stoichiometry. Stoichiometric ratio is 1:1. That's why we can get at 1:1. That's why we are getting sulfate equals to barium sulfate equals to sulfate. So we go from here to here. Moving on. Just give it a try by yourself. All the steps are on your note. You can copy down, but try to finish. Fill this part, this sentence, this paragraph, fill it. Done. Good. Determination of SO4 2- ion concentration in a given solution. Take a known volume from the sample. Now you're going to look at your note. Add excess barium chloride solution and dilute nitric acid. Filter the precipitate and let it dry and get the mass. Continue drying and weighing until a constant mass obtained. And then equation, calculation part. Then barium chloride solution should be added in excess to precipitate all SO4 2-. If the sample consists carbonates, phosphates or sulfide, these ions also can precipitate as barium 2+ source. This can be prevented by adding dilnitric acid to get dissolve these. Okay, questions are very rarely. Okay, big question part finding the concentration. Finding the concentration is a very little part of a big question. Okay, it's not important. It's important, but very minor. Okay, අපි යමු දැන් major part එකට trigonometric methods. Titration එකක් මේ ඔක්කොම යන්න කලින් මම titration එකක් මොකක්ද කියලා චුට්ටක් ඔලුවට දාන්න. I know you guys did this for you all well. Let's say we have two compounds, let's say A and B. We know what is A. What is A? We know that. And we know what is B. Let's say we are going with KMnO4 and Fe2+. We know what is KMnO4. We know what is in A, that is KMnO4. We know what is in B, that is Fe2+. That is a requirement. Cool. And then the second thing is, we know the concentration. We know the concentration of one. We don't know the concentration of the other one. This is a requirement for any titration. Known two compounds, known one concentration, so that having a connection between A and B, we find the concentration of unknown. We find the concentration of unknown. That is the titometric method or the titration. That titration we divide into 3 different parts by measuring the volume that you done in all levels, by measuring the volume of unknown to known. Then the second one is the potentiometry, and then the last one is the conductometry. Potentiometry means we are measuring the potential difference. Conductometry means we are measuring the conductance. Why we need potentiometry and conductometry when we cannot use the volumetry? When we cannot use the volumetry, let's say we don't have a proper indicator. Let's say the concentration is really lower. In such situations, when we cannot use a normal titration, we are going with these 2 different methods. These 2 methods are out of syllabus. We are not doing anything with these. You only know these 2 names. So the part we know is the volumetry. That volumetric analysis we divide into 3 different parts. If we are using just a normal acid-base reactions, that is called what? The neutralization. In between, if a redox reaction is going on, like potassium permanganate Fe2 plus, one is oxidizing, other is reducing, that is a redox type. Again, during the titration, if it is making a precipitation, that is called precipitation volumetric analysis. Redox, we divide into 2 different parts, normal and iodometry. During the redox reaction, if I2 is involving, that is iodometry. All the other reactions are normal redox reactions. So these 2 are the parts we are concentrating on. You have 3 reactions of normal titrations and 1 single reaction of iodometry. This is the most complicated part. Then once you've done this iodometric part, we are done this analytical chemistry, this titration part. Okay. So, මෙතන පටන් ගන්න. If you just read කරන්න. Break එක ඉවරලා මේක start කරමු freshly. Okay, 425, 435, 440. 441 word end on exactly because the time is 426. The high, 441 word මම එනවා මෙතනට. Okay, starting from the topic. Are there spaces? No, there are no spaces there. In order to determine the amount of substance, a titration can be carried out. Classification of titrations. Okay, copy these 3. These parts are right. Let's write together. These parts are like not clear. Let's write together. Let's write together. It's right. Determination of concentration of under volumetry, that's right. Determination of concentration of a solution using a volume of standard solution. Determination of concentration of solution using a volume of standard solution. Okay. Under potentiometry, that's right. And analyzing a chemical by measuring electrochemical potential. Analyzing a chemical by measuring electrochemical potential. Conductimetry. That's right. Analyzing a chemical reaction. Conductimetry. Analyzing a chemical reaction by measuring electrical conductivity. By measuring electrolytic conductivity. By measuring electrolytic conductivity of the reaction mixture continuously during the reaction. Of the reaction mixture continuously during the reaction. Of the reaction mixture continuously during the reaction. Continuously during the reaction. Okay, then this part, neutralization, redox, precipitation, redox, normal and iodometry. Redox, normal and iodometry. Neutralization, redox, precipitation, normal, iodometry. Iodometry means this is releasing I2. All the other redox are normal redox. Finished? Okay. So the next topic, conditions that should be fulfilled in titometric analysis. Titration එකකට only requirements මොනවද කියලා. Okay, so let's say we are going with I'm going to go with one of the simplest one. Let's say we are going with potassium permanganate Fe2 plus reaction. Let's say KMnO4 concentration and the Fe2 plus. We know the compounds and we know the concentration of KMnO4. We need to find the concentration of Fe2 plus. Then there must be a simple reaction. For the simple reaction, the reaction between potassium permanganate and Fe2 plus. We should know their stoichiometry. How much moles of potassium permanganate reacts with how many moles of Fe2 plus. And then the second thing is, when we are doing a titration, we cannot do it like for ages. The reaction is supposed to have some sort of a speed, not too fast, not too slow. So it's supposed to be relatively faster. We are supposed to have some sort of a speed. The reaction is supposed to maintain itself some sort of a speed. And how do we know a reaction has gone to its end point? Some sort of observation. So there must be an alteration in physical or chemical property. Some sort of a something inside the reaction supposed to be changing. Potassium permanganate Fe2 plus, what is the color change? Let's say we started from potassium permanganate, then the color change goes from what? Pink to colorless, or either colorless to pink. Some sort of a color change supposed to be there. Let's say that you don't have something inside the reaction mixture. Let's say it's not working, like there are like both are colorless. Then what's supposed to be do? We have to use some sort of an external indicator, such as starch. Such as, like, there are a couple of these indicators, phenolphthalein, methyl orange, bromothymol blue, all those are indicators. You guys know methyl orange and phenolphthalein, I guess. If there are no such any of those, then we are going with the potentiometry and conductimetry. If we couldn't find any physical or chemical changes that we can see observation, then we measure the potential difference or conductivity during a reaction. So by these changes, we can define the endpoint. So these are the requirements. Naturally, these are the requirements that they are supposed to be, that we can move on to a titometric analysis. Let's read this together. Conditions that should be fulfilled in titometric analysis. This part is simple. Okay, number one, there must be a simple reaction which can be expressed by a chemical equation. The reaction should be relatively fast. Number three, there must be an alteration in physical or chemical property of the solution at the equivalence point. Number 4, an indicator should be available. If there is no visible indicator, some other property can be used. Example, potentiometry, conductimetry. Okay, fill this part. Are there spaces? I didn't leave, yeah, there are spaces. I didn't leave many spaces like for analytical part. Initial color කියන්නේ colorless නේ. අපි මොකේද color එක බලන්නේ? Titration flask එකේ. So what's the initial color? This is colorless. Then what happens once you add potassium permanganate? Once whatever this compound is finished, next drop of potassium permanganate gets here, gives the color. So the color goes from colorless to pink. Colorless to pink. Anyway, so the burette එකට දාන එකනා usually, not always, මේ ඔක්කොම questions වලට ඇහෙන දේවල්. Usually this is a non-solution. අපි ඉස්සලාට standard කියලා word එකක් ලියුවා note එකේ. Standard කියන එකේ meaning එක තමයි we know the concentration. Non-solution is for the standard one. then ඒකට තව නම් කීපයක් මෙගලන් දීලා තියෙනවා මේ titrant or standard solution is the non one. Usually that comes to burette. And then once you do the titration, let's say we are adding oxalate here, we don't want external indicator because potassium permanganate is given the color. Exactly 25.00 measuring from the pipette and introducing to the titration flask. Then we fill this burette with the potassium permanganate, then we are adding little by little. So the very first time initially, whatever they're adding potassium permanganate is reacting with oxalate. Once the oxalate is finished, then the next drop of potassium permanganate adding here gives the color. So for that, we need to use some sort of amount of potassium permanganate so that the burette reading, the amount of volume we are using from potassium permanganate is called titer or burette reading. Titer or burette reading. This is the titration flask and that part is okay. And then the titration flask that we are introducing from the pipette, that is called titrant. Titer here, okay? This is titrant, T-I-T-R-A-N-T. Titrant is the standard solution. This is titrant. Only difference is D here. D here. This is the unknown one. Standard solution is a titrant. Unknown solution is titrant. Clear that? Okay, so one single letter difference is there. So from the pipette, the unknown one, that's again usually, but that totally depends on the reaction condition that we need, that we usually going on. So those are the words that they are explaining here. Cleaning part එක අපි පස්සේ යමු නේද? මේක ඉවර කරගෙන ඉමු. Okay, so the very first one is the titrant. What does titrant mean? Burette solution or the standard solution. What is that? Reagent of non-concentration. Non-concentration is what? Titrant. Non-concentration is standard solution or titrant, or that is the burette reading. Usually this is come on to burette. Then the titrant D. What is the titrant? This is the unknown one. Unknown one. The substance being titrated to find the concentration. Usually this is in the titration flask. This is in the flask. There is the titrant. Titer. What is the titer? Burette reading. That volume is the titer. Volume required to reach the endpoint. Endpoint volume is the titer. Titrant volume or the burette reading. So that's in the burette. That's in the burette. මේක ගෙදර ගිහලා ආයෙ බලලා මෙමරි කරගන්න ඕනි. I am doing to a certain level but I cannot do everything. පාඩම් කරේ නැත්තම් ගොඩ යන්න බෑ. මම සෑහෙන හරියක් කරනවා. but ඒකෙන් විතරක් යන්න බෑ කියලා මතක තියාගන්න ඕනි. So the end point එක කියන්නේ මොකද්ද? So ඔන්න දෙකක් අපිට මෙතන ගන්න තියෙනවා end point and equivalence point. ඔන්න ඔය දෙකට දැන් අපි යමු. ඔන්න හිතන්න that this stoichiometry is 1:1. potassium permanganate and oxalic, let's say the stoichiometry is exactly 1:1. Let's say I'm adding 25, exactly 25.00 cubic centimeter of oxalic here. So let's say the 0.1, same 0.1. Same 0.1 oxalate with a 0.1 KMnO4. If the stoichiometric ratio is 1:1, if you are using 25 cubic centimeter of oxalate, how much potassium permanganate needed? What's the volume? Same amount. මේකෙන් 25 නම් මේකේ 25ක් වගේ වෙනක් ලියුණාද? මේකෙන් අපි දැන් 25 නේ ගත්තේ. එකම number of moles නම් තියෙන්නේ to neutralize this 25 මේකෙන් කොච්චරක් වුණාද? 25 වුණ වෙනවා. Assumption, okay? ඔන්න ඉතින් මේකේ 25 වුණ වෙන්නේ කියලා. So මේකේ 25 තියෙනවා. ඒතර අපිට මේකේ exactly 20.00 වුණ වෙනවා. Okay, now when we are adding this, so this is pink color. So pink color potassium permanganate I'm adding to the titration flask. Little by little, what happened? When we are adding one single drop, one of the drop එකක් දාලා මේක පාට වෙනවා. ආචුට එකේ මොකද වෙන්නේ? මෙයා react කරනවා oxalate එක අර පාට නැතිලා යනවා. Again we are adding another drop. Again we are adding another drop. Again this is become pink color. Then what happened again? ආයෙත් මෙයාව neutralize වෙනවා oxalate එක react කරලා. Over continuously this is happening, but once when all the oxalate are finished, then what happened? Then the next drop of potassium permanganate just existing here, because since there are no oxalate anymore, this potassium permanganate is just existing freely. That oxalate is not there to react, so that potassium permanganate gives its pink color. Clear there? මේ pink color එක එද්දී oxalate කොච්චරක් ඉවර වෙලාද? Exactly 25.00 ඉවර වෙලා නේද? ඔන්න අපි හිතමු exactly 25.00 මේක ඉවර වෙනකම් මේකේ potassium permanganate දැම්මා කියලා. Only to react exact amount of oxalate, we are adding exact amount of potassium permanganate. Then එතකොට මේකේ color එක මොකක්ද? We added only to react the exact 25.00 oxalate. Then what's the color of titration flask? Can colorless. තේරෙනවද? Because let's say දැන් අපි drops වලින් ගන්නකෝ. හිතනවා මේකේ drops 1000කට මේකේ drops 1000ක් කියලා. So දැන් අපි 999ම දාලා ඉවරයි. But still this is colorless. අපි අර last drop එක මේකට දානකොට මොකද වෙන්නේ? Make a next drop again. Potassium permanganate last drop is again neutralizing. So again the color is colorless. Clear now? That point is called the equivalence point. Equivalence point. Exactly how much you need to react with each other. That is the equivalence point. Equivalence point is a theoretical something. Theoretically, 25.00 of potassium permanganate needed, 25.00 oxalate. But we don't see a color change. To see a color change, we have to add what? Excess of potassium permanganate. One excess drop. That there is no oxalate to react with that. But that excess drop gives the pink color here. Then we see obvious color difference. That is called the end point. End point is the one that we see the observation. Theoretical end point is the equivalence point. At the equivalence point, reaction is already completed. Reaction is already completed at the equivalence point. But without adding excess drop, we don't see the color difference. Can you guys see the difference between end point and equivalence point? Okay. Now tell me end point volume. Equivalence point volume. Which one is greater? දැට අහගෙන ඔළුව ගනුවනේ. දැන් දෙන්න උත්තර. Which value is greater? End point or equivalence point? End point value is greater. Why? Equivalence is exactly 25.00 to 25.00. When we are adding excess point, that gives the color difference. That is the end point. Clear there? So always end point is greater than equivalence point. Unless otherwise there are a couple of little situations that exactly once the exact amount is reacting with exact amount, they are giving some sort of a observation. So unless otherwise, if they are not giving observation at right amount, then we have to add little excess to see the color. Then at that time, endpoint is greater than equivalence point. ඔය දෙක. මේ බලන්න. So that the equivalence point, theoretical point, stoichiometric endpoint. Stoichiometrically, so reaction is completed at equivalence point. So pratikriya sampurna වන ලක්ෂ්‍ය. The point at which reaction is completed. Reaction is completed, but there is no observation. So to get the observation, we have to add excess. අපි දන්නේ නැහැ colorless මේ colorless තියෙන reaction එක complete වෙලාද ඊට කලින්ද, we don't know that. So that we have to add excess point. Once we add the excess point, we know drop before that is the reaction completion point. That is the equivalence point. Equivalence point. End point. End point, the point at which a clear visual change can be observed. Visual changing when the end point, real end point, equivalence point at that time on the reaction is fully completion. So that there is this volume difference that is called the titration error. Titration error is the difference between the end point and equivalence point. क्या दो automatic हरे. Okay, so මේ ටික දැන් ඔයාලට memory වෙන්නේ නැහැ. මේ part එක memory කරගන්න magic එකක් අපිට නැහැ. අපිට computer brains නැහැ නේද? Human brains නේ. So you guys have to study this part. Study කරන්න ඕනේ. කියන්නේ inorganic continuously study කරන්න ඕනේ if you need this magical. හරි මෙතන මේ ටික අපි පොඩ්ඩක් read කරමු. Even titrants, the reagent of non-concentration solution in the burette, or you call it a standard solution. Number 2, titrant, the substance being titrated to find the concentrations. Solution in the flask normally. Okay, remember normally. Number 3, titer. Titer, volume required to reach endpoint. Titrant volume or burette reading is same, titer. Number 4, endpoint, the point at which a clear visual change can be observed. Number 5, equivalence point or theoretical point, stoichiometric endpoint VEQ, the point at which reaction is completed. Titration error, the difference between endpoint volume and equivalence point volume. Usually 1 drop of titrant is 0.05. Well, experiment exactly very accurately karana. So when you are adding one single drop is supposed to give the color difference. Single drop volume is 0.05 cubic centimeter. So we can neglect that little volume. So we are taking exactly 25.00 to 25.00. Clear that? Okay. Terms used in titrations. Terms used in titrations. Okay, feel this. Okay, copy the rest. Copy the rest. The point at reaction is completed. Next topic. Standard solutions. Okay, what is the standard solution? The one which having the non-concentration. The one which is having the non-concentration, that divided into two different parts, primary standard and secondary standard. Primary standard solutions are you can use directly. Directly you know the concentration, you can use that solution directly because primary standard solutions are really stable. Let's say we have compound A. A is reacting with B and B is reacting with C. But there is no direct reaction with A and C. Let's say C is the primary standard. This is the primary standard. But C doesn't react directly with A. Let's say you find the concentration of A. Then what do we need to do? We find another middle chemical which is reacting with A and C both. Then we make C react with B. And then by that we find the concentration of B. Knowing that we can make B to react with A. C is a primary standard solution. So B become the secondary standard solution. We cannot directly use B because let's say it's impure or its stability is less. Whatever the reasons, we cannot directly use B as a primary standard. It doesn't have primary standard qualities. But still, since C doesn't react with A, we are using B to react with A. To standardize B, we are using C. C is the one like, the stable one. So C become the primary standard, B become the secondary standard. That is the difference between primary and secondary standards. Are you guys okay? What's the meaning of standard solution? Concentration is known. So we know the concentration of C. By that we find the concentration. We know the concentration of C. By that we find the concentration of B. You reacting with B, we can find the concentration of A. Okay. So standard solutions are primary and secondary. The solution of accurately known concentration. So we know the standard solutions concentrations. These can be classified into two, primary standard and secondary. Primary and secondary. So the primary standard solutions. Primary standard solutions. See, you guys can understand these are little complicated. So focus really well. Primary standard solutions. A solution that can be prepared with exactly known concentration. So this concentration we can exactly know those are the primary standard solution. Know the exact concentrations. When you go with the secondary standard solutions, this cannot be prepared with exactly known concentration, but the concentration can be calculated by titrating with a primary standard solution. So secondary standard solution doesn't have exact concentration, but we can standardize. We can find its concentration by titrating with another primary substance. Those are called the secondary standard solutions. On a common idea, let's move on to talk about why we call some compounds as primary standard and what are their properties. Okay, let's read this part together. And let's fill your note. Let's read together. Topic: standard solutions. The solution of accurately known concentration. These can be classified into two. Number one, primary standard solution. A solution that can be prepared with exactly known concentration. Number two, secondary standard solution. These cannot be prepared with exactly known concentration, but the concentration can be calculated by titrating with the primary standard solution. Just fill that part. කතා නොකර හොඳට focus කරගන්න. Standard solution, the solution of accurately known concentration. These can be classified into two. Primary standard solution, a solution that can be prepared with exactly known concentration. Secondary standard solution, these cannot be prepared with exactly known concentration, but the concentration can be calculated by titrating this with primary standard solution. Tutor questions ගන්නත් තියෙනවා ටිකක්. මම අද ටිකයි කරන්නේ ඔයාලට. Okay, primary standard substances. Anything that we use to make primary standard solutions are called primary standard substances. They're supposed to have sufficient purity. Usually we consider as purities like 100% Himalaya, from which a standard solution can be prepared by directly. We made the mass, exact amount, then we dissolve it in water and then dilute to give exact defined volume. Knowing the mass divided by mole mass is the the number of moles. That if we measure to exact volume, then we know the concentration. That kind of solutions are called primary standard substances. මෙයා තමයි තියෙනවනේ exact qualities වෙන්න ඕනේ. Characteristics of a primary standard substance. See, it must be easy to obtain. Obtain එක easy වෙන්න ඕනේ. අයි අපේ lab එකේදී easily work කරගන්න. නැත්නම් like let's say it's really hard to find අපි මේවා order කරලා නේද මාස ගණන් බලාගෙන ඉන්නවනේ chemical එකක් එනකම්. So easy to obtain and to purify. Easy methods purification නැතුනොත් again experiments taking time and costly. To dry, to present in pure state. Once you purify and dry, it's supposed to be stay in as it is. It's supposed to be stable. The substance should be unaltered in air during day. Non-hygroscopic. So it cannot absorb water. Hygroscopy means absorb water. So it cannot absorb water. And then even we make this initial primary solution, there are supposed to be some sort of a method to make sure. Man-made errors තියෙනවානේ හිතන්න බලන්න exact mass එක measure කරනකොට mistake එකක් වුණා කියලා. Then you're supposed to find another way to find the concentration of that solution you made as the standard solution. That is the third one. The substance should be capable of being tested for impurities by qualitative and other tests of non-sensitivities. Some sort of a sensitivity test supposed to be there to measure their own concentration. It should have a high relative molar mass. When the relative molar mass is greater, even if there's a little the mistakes coming through the mass, it's become negligible. The substance should be readily soluble under the condition which it is employed. Let's say usually normal, let's say your advanced level laboratories, we are always doing the medium as taking as the water. So these are supposed to be dissolved very easily in water. The reaction with the substance, standard solution should be stoichiometric and practically instantaneous. So it simply means with the standard solution to the unknown solution, they are supposed to be this. These are like the last one we were talking about. They are supposed to be stoichiometric relationship plus reaction supposed to be faster. Alright, medical read karala, then let's fill. 208. Let's read. Characteristics of primary standard substances. It must be easy to obtain, to purify, to dry, and to present in pure state. The substance should be unaltered in air during weighing or non-hygroscopic. Number 3, the substance should be capable of being tested for impurities by qualitative and other tests of non-sensitivities. Number 4, it should have a high relative molar mass so that the weighing errors may be negligible. Number 5, the substance should be readily soluble under the conditions which it is employed. The reaction with the standard solution should be stoichiometric and practically instantaneous. Done instantly mean like within seconds that you would see the color difference between this potassium permanganate oxidate. All of a sudden it's usually maintained colorless. All of a sudden it's become pink. That kind of a speed they're supposed to maintain. Fill it. හරිද? Okay, primary standard substances. ඒකේ පොඩි එකක් තියෙනවානේ with a standard solution. අර මෙතන ස්පේස් එක නෑ එතන දාලා ලියන්න ඕනේ එක with a standard solution. With a standard solution. Okay, rest of the part. Can I move on? Okay, copy the rest. Yeah. Now, common primary standards, once you write that part, let's finish. I'll read this part again once you write. Finish. Okay. You're going to check your note, okay? You have to memorize these three examples. For the exam, directly they are asking these compounds. Which is the standard solution, standard substance. Common primary standard substances. For acids, we are using sodium carbonate and sodium tetraborate. For bases, sodium hydrogen phthalate, potassium hydrogen phthalate. Redox, you guys know all these. Potassium dichromate, potassium bromate, potassium iodide, and sodium oxalate. Okay, common primary standard substances. Okay, read this. Sodium carbonate, sodium tetraborate, again, sodium carbonate, sodium tetraborate for acids. Okay, for bases, potassium hydrogen phthalate. Next one, potassium hydrogen iodide, again, potassium hydrogen phthalate, potassium hydrogen iodide, potassium hydrogen phthalate, potassium hydrogen iodide. And for redox, potassium dichromate, potassium bromate, potassium iodide, sodium oxalate, again, potassium dichromate, potassium bromate, potassium iodide, sodium oxalate. Okay, copy this. Not necessarily you need these structures, not necessary. If you want, you can copy this down. Okay, let's stop in this analytical part today from here. Next week, you're going to move on to this most complicated part. After this one, let's move on to the tute. Structures are not necessary, but you can go with that. Okay, let's move. Let's finish this from here. So we're going to start the next part. Okay, the tude book. What you're supposed to remember is, okay, you guys can leave. Yeah, is it's not that you can go without questions. It's a must that you guys need questions. And for that, you have to complete the full tude. Once you've done the full tude, you would feel that inorganic is comfortable. I don't think we can do a full tude here. So I'm going to do a part, then I'm going to send you guys recording. Then you're going to get through this with recordings, okay? And the other thing still, since we were not completing with this analytical part, getting answers are still challenging for you guys. Some answers are not that easy to understanding without the analytical part. Anyway, let's move on to the question number 33. මේ සෙට් එක බෝඩ් කරගන්න ඕන කවුරු හරි ලංකාවේ ඉන්නවනම් The reaction of sulfur and sodium hydroxide. Okay, my turn. Akindu, my turn to talk. The reaction of sulfur and sodium hydroxide is an example for a disproportionation reaction. You guys supposed to remember sulfur sodium hydroxide reaction plus දැන් මෙහෙම එකක් අහනවා කියලා ඔයගොල්ලෝ දන්නවනේ. ඒක නිසා when you are analyzing equations, analyze whether those reactions are disproportional or not. So the zero oxidation number, high oxidation number plus 2, low oxidation number minus 2. Yes, that's a disproportionation. First statement is correct. Okay, the second statement, when an element is simultaneously oxidized and reduced, it is called disproportionation. See, one single sulfur element at the same time going through the reduction and through the oxidation, so that they are going to lower and high oxidation numbers, so that they are showing the disproportionation, so that the question number 33 answer 1. Question number 33 answer 1. Raise your hand if you don't have the tude. Who didn't bring the tude? Tude එක ගෙනාව නැත්තම් එක්කන ලියන්න ඕනේ ස්ක්‍රැච් පේපර් එකක යාළුවට ඩිස්ටර්බ් නොකර ඉන්න ඕනේ. Every day it's a must to bring the tude. Which of the following statements regarding size of ion formed by S and P block elements false? Wrong statement is asking. Cations are always smaller than their neutral atoms. Since electrons are removing, electron number is less than proton number. Therefore, nuclear charge or the proton number is increasing. Also, since outermost electrons are removing, shielding effect is also less. So that squeezing of electron cloud so that the cationic radius is less. So that the first statement is correct. Anions are always larger. That's again true. Now in anions, electron number is Akindu greater than. Electron number is now greater than proton number. Also shielding effect, number of electrons are high, means shield effect is also greater. So the nuclear attractions are decreasing so that the size is larger. That you can understand easily. The size of cation decreases from left to right across a period. That's number of proton increasing, electron attraction increasing, electron cloud squeezing. That's true. The size of anion also decreases from left to right across a period. That actually is the answer. When about 2016, and they are continuously asking these kind of questions. So even if you, let's say that you don't have a prior preparation for such questions, then answering is really challenging. The size of anions formed by elements of second period. I have taken a couple of anions, nitrogen 3 minus, nitrogen 3 minus, oxygen 2 minus and F minus. And other part is larger than the statement. Cations formed by elements of the third period. So that I am moving to the third period, couple of these cations, sodium plus, magnesium 2 plus and aluminium 3 plus. If you count, all their electron number become 10 once they make these ions. So that is isoelectronic. If it is isoelectronic, how would you go? Positive charge increases, radius decreases. And then negative charge increases, radius increases. So that statement larger is true. Statement 5 is again correct. So that question number 34, answer 4. Okay, note down everything. See how nicely you can analyze these. Just memorize these knowledge. Like whatever the questions you do, memorize them before moving to the next part of questions. And I want you guys to do these questions ahead of me. Don't wait until I do everything and you are just copying down like theory. This is not theory. Isoelectronic 10 electrons. Positive increases, radius decreases. Negative increases, radius increases. Anions are so that it's larger, so that it's larger. Go through the note, read the theory when you are doing these questions and make sure that you do these questions ahead of me. It's not the person who has challenge win this game. It's the person who has effort wins the game. Don't forget that. Actually, how is Manisha now? How come she get the rash? With touching with something or like on health condition? Question number 35. Which of the following statements concerning water is true? It can act as an acid, Lowry-Bronsted, C, H2O, reducing H plus and converting to OH minus, donate H plus, acidic. It can act as a base, see here, H2O, taken up H plus, accept H plus, basic, C, H3O plus. So this is, just write the word for your practice, Lowry-Bronsted, Lowry, Lowry-Bronsted. It can act as a reducing agent. See the reaction here. Water reduces, not this one, this one. Reducing agent. Water is reducing fluorine oxidation number from this 0 here to minus 1 here. See, it's reducing from 0 to minus 1. So acting as reducing agent. This one, this purple one. This purple one is just for your reference. Answer is the pink one. See the oxidation number from 0 to minus 1. Reduction acting as a reducing agent. So this is all correct. So D is supposed to be correct. Question number 35. A, B, C, D all are correct. Answer 5. 35, answer 5. Question number 36 actually is directly theory. So you're supposed to have this memory between sulfur and nitric acid. Okay, we did two different reactions. අපිට මෙතන hot කතාවක් කියලා නැහැනේ නේද? අපිට මේකේ hot කතාවක් කියලා තිබුණා නම් මෙන්න මේක hot කතාවක් කියලා නැහැ. So we are going with the normal equation. This is number 3. Number 2. Answer 2. Question number 36, answer 2. Question number 36, answer 2. If it is hot, the blue one. Normal answer, answer 2. Because they were not mentioned in the temperature. Raise your hand if you got the answer 2. Good. So every day we are doing a couple of questions. Make sure that you do this ahead of me. Magical results ආවම සමහරක් අයට යාළුවෝ ගොඩාක් painfully හිතනවා ඇයි යාට ගොඩාක් හොඳ result එකක් ආවද මට නැද්ද කියලා. ඉතින් ඒ වෙනස මේ class එක මැදම දකින්න. Like some students are raising their hands, doing really good job. So ඒගොල්ලන්ගේ එතකොට every day ඒගොල්ලන්ගේ workout එක වැඩි. When you are working out every day, your results are going to be amazingly high, fabulously high. Work every day. Moving on. Chlorine reacts with sodium hydroxide. Okay. So they were not given this one, conc ammonia HCl, sodium hydroxide HCl, but ඒක දීලා නැහැනේ. මේක දීලා නැහැ. ඉතින් අපිට දීලා තියෙන්නේ deal condition එකත් එක්ක. So මෙතන aqueous එක අපිට මෙතන deal කියලා හිතලා ගන්න පුළුවන්. So this actually is a Milton solution. Question number 37, answer 4. 37, answer 4. Directly theory, I have no explanation here. Get the answer from the theory simply mean for the final exam, you have to have everything in your memory. Just go with memory. Just go with memory. I mean with the book for now, but for the exam, go with memory. Question number 37, answer 4. Have a separate time each week to go with this student book. Let's say each week you are doing, let's say each day you are doing like 10 questions. Is it hard to do 10 questions a day? To complete 300 questions. How many days? 300 something තියෙනවනේ. Don't go with the normal path. Don't go with what others are planning. Go with a special plan that only special for you. Do better than others if you want better results. Question number 38. Concerning H2SO for true part is asking, it oxidizes sulfur. It oxidizes sulfur. When a sulfur reaction occurs, so all the other four are wrong. Concentrated H2SO4 reacts with sulfur and give SO3. No, that's wrong. This is not SO3, this is SO2. SO2 here, that's why it is wrong. Carbon 2, carbon dioxide, that's again wrong. Carbon monoxide is carbon dioxide. Not reacting wrong. 4 and 5 are definitely wrong. Question number 38, answer 1. 38, answer 1. Sorry. Question number 39. That's why you need the memory of these members of all groups. So they were asking something about acetyl. Before moving in the question, you should know what is this acetyl. Group 17, fluorine, chlorine, bromine, iodine, astatine. See, they are allowed to ask. Oxidation number for hydrogen is +1, astatine is -1. We know nothing about the astatine. But let's say that we know like astatine is more closer to chlorine. You guys know the fluorine reactions are always different. And we have done reactions with bromine and iodine as well. So that's also closer to astatine. So the oxidizing ability of these two are greater than these. Let's see. Does not act as a reducing agent. Even without any particular background knowledge, we can get this answer. Because here the oxidation number is -1. It's normal oxidation number. It is usually existing as astatine 2. Like F2, Cl2, Br2, I2. So it's supposed to be AT2. So that's supposed to be possible. Then I'm giving some sort of extra information here, background information. HF and HCl cannot be oxidized by acids. මගේ short note එකේ ඒවා තියෙනවා. I'm once we done this, okay? So, to convert Cl- to Cl2, more strong oxidizing agents needed like potassium permanganate or manganese dioxide. But to oxidize HBr and HI, HBr to Br2 and HI to I2, these acids are possible. Sulfuric or nitric you can use so that we can consider astatine do the same as Br2, I2. With nitric and sulfuric kind of acids, astatine can reduce up to AT2. So that's possible. So that the first statement is incorrect. Second statement, in hydrogen astatine, astatine is in an oxidized state. Oxidized means the high oxidation number, but here it is showing group 17's lowest oxidation number. So it is in reduced state, not in oxidized state. This is wrong. Not oxidized, it is in reduced state. So that both statements are incorrect. Question number 39, answer 5. HI reaction HI with H2SO4. Same way we can get the reactions of acetylene as well. 39, answer 5. අහලා නැති එලිමන්ට් එකක් ගැන එක්ස්ප්‍රෙෂන් එකක් තිබුණා කියාගෙන ගෙදර යන ළමයිනුත් ඇති ඉතින් නේද? While I explain, don't write, just listen. Because otherwise you are just waiting until others are writing. If you are really comfortable, that's okay. If you guys are really comfortable while I'm teaching, you guys can write. But sometimes you may missing points. This message I have written the last week 2026 students. Now you all know how perfectly you need inorganic knowledge to complete equilibrium tube. Do inorganic again. Because they were complaining like inorganic amataka vela. For equilibrium you need big inorganic. Question number 40. Which one of the following cannot be used to distinguish between KBr and Ki? Directly it's difficult because both these are like, these colorless compounds group 1. But if we oxidize these two, Br2 red brown, I2 purple, or otherwise precipitate silver bromide, silver iodide, or lead bromide, lead iodide. There are different ways. For that part, you need that 20 cation, 12 anion, that little. Okay, so the very first one, aqueous silver nitrate and dill nitric. See, again, they are talking about the dill nitric. That's to avoid other precipitations are coming. So that silver bromide is pale yellow, silver iodide yellow. You have to memorize separately. So the first one is okay. I'm moving to the second one. Lead story is the same. Lead bromide white, lead iodide yellow. Okay, this little part, we still didn't do this part, okay? Lead set and silver set are specifically, they are continuously asking this way. Lead iodide, once you heat, it is giving this, lead iodide has this golden yellow color. And once you heat it, it is become aqueous colorless. Golden yellow become colorless. And once you cool it again, this is come back to give this golden place. That's for lead iodide. If it is lead chloride, if it is the same way, if we go with lead chloride, if this is PbCl2, if you heat it, this is become again aqueous colorless. Once you cool that down, that gives the white color needle-like structure. So those specific identification tests are there. Anyway, you can get separate colors for these precipitates. So the second one is also correct. Q. And then concentrated H2SO4. අපි අර කලින් question එකෙත් කතා කරේ නේද? කලින් question එකෙත් අපි කිව්වා fluorine chlorine නෑ. But Br minus to Br2, I minus to I2, with their colors we can identify. See, I have in the sulfuric equation here. With Ki, only Ki here, this is giving first Hi and then I2. That's also possible. The same way, nitric do the same way. And also on reactions with nitric, I have also shown here Ki reaction and KBr reaction gives I2 and Br2. So that fourth one is also possible. CCl4. CCl4 to give colors, they are supposed to be Br2 and I2. So I2 CCl4 layer is purple, Br2 CCl4 layer is red brown. By that we can identify, but not CCl4 in these ionic compounds. There is no even dissolution. Okay, question number 40, answer 5. Sorry. Copy this. Question number 40, answer 5. අම්මට තාත්තට ආදරෙන් සලකන ඇතුසන්න. මේ ෆර්ගසන් එකේ 2026 අටි කෙනෙක්ගේ අම්මා කෙනෙක් මේ ගිය සතියේ නැතුණා කියලා ඔබට ගන්න. අද ගෙදර යද්දී උගලෝ දැනගත්තොත් ඔයාගේ අම්මා මැරිලා කියලා. ඒ අම්මා මැරිලා. දැන් ඔයගොල්ලන්ගේ අම්මා මැරිලා කියලා ඔයගොල්ලන්ට ගෙදර ගියන් දැනගන්න හම්බ වෙනවා නේද? ඔයගොල්ලෝ සුයිසයිඩ් කරගන්න නැහැ ජීවත් වෙනවනේ නේද ජීවිත කාලෙම අම්මා නැතුව. දැන් එහෙම අම්මා කෙනෙක් ළඟ ඉන්නවා. අම්මා දුක් විඳිනවා මහන්සින අම්මා කියන්නේ ගෙදර සර්වන්ට්ද. මම අහන්නේ නැහැ කාගේ ගෙදරද සර්වන්ට්ලා ඉන්නේ නැත්ද කියලා. හැබැයි අම්මා තාත්තා කියන්නේ සර්වන්ට් නෙවෙයි නේද? මහා 16ක් නෙදේ උනාට. අම්මා තාත්තා සර්වන්ට්ස්ලා නෙවෙයි හැබැයි 16ක්ටත් ඒවා වැඩ කරනවා. මහා පාන්දර නැගිටලා ඕගොල්ලෝ නිදි වෙලාවේදී නේද කිරි එකක් හදලා පැත්තකින් තියලා ඊට පස්සේ උයලා ඕගොල්ලන්ට ඒගොල්ලන් කෑම කියන්නේත් කවුරු ගැන හිතගෙනද? ඔයාලා ගැන හිතලා. ගෙදරට කෑම කියන්නේ කවුරු ගැන හිතලාද? අර පුතාට අර කාසයි මේ දුවට මේක ආසයි කියලා ගන්න තරම් අර බ්‍රොෂර් ෂොපින් කරන්නේ ළමයිට ගැන හිතීතා ළමයිට ආස කෑම. අම්මලා තාත්තට සාමාන්‍යයෙන් ආස කෑම කන්නේ නැහැ ආස ඇඳුම් අඳින්නේ නැහැ. හැබැයි ඔයගොල්ලන්ට ටියුෂන් ෆීස් වලට එක දවසක්වත් අනේ අම්මි මට එතන කියලා පල් වෙන්න බෑ. නැත්තම් අර එතන සැර දානවා බයිනවා කියලා ටියුෂන් ෆීස් එකම අඩු කරන්නේ නැහැ නේද? ගෙයින් එඩිට් කරනකොට කොයි දේවත් අඩු කරන්නේ නැහැ නේද? මොන දේද කියනකො අඩු කරන්නේ? ඕගොල්ලෝ රිච් උනත් ඕගොල්ලෝ පුව උනත් අම්මා තාත්තා සාමාන්‍යයෙන් දිය හැකි ප්‍රමාණයට වැඩි මාර ප්‍රමාණයක් දෙද්දී ඕගොල්ලෝ ණය ගෙවන්නේ කොහොමද? කොහොමද ණය ගෙවන්නේ? පාඩම් කරලා වැඩ කළා මහන්සි වෙලා. ඉතින් ඒක හිතේ තියාගෙන වැඩ කරන්න. ඊට පස්සේ මම දන්නේ නැහැ එක එක කතන්දර බ්‍රෑන්ඩ් එකක් සෙට් වෙනවා. එළියදී ඕන් දැක් කරගන්න. හැබැයි බ්‍රෑන්ඩ් එක කියලා කියන්නේ ඔයගලන්ගේ අම්මලා තාත්තලා ඔයාලව බ්‍රෑන්ඩ් එකට එවන්නේ මාර විශ්වාසකින් මට අම්මලා තාත්තලාම කියන මේ ගේට් එකෙන් අස්සට දැම්මට පස්සේ මගේ ගෙදර ඉන්න වගේ මට ෂුවර් ඒක නිසා මම බය නැතුව දාලා යනවා කියලා. අද නම් ඔයගොල්ලෝ ටිකක් මැචුවර්ඩ් නේ. හැබැයි ඔයගලන්ගේ අර ඕල් වල ඉවර වෙලා අතින් අරලා ළමයි දැන් රයිසිම් එකේ සමහරක් ඔය සීවල එකට යන සමහරක් අය මට කියනවා අනේ මඩම් කවදාවත් ළමයාම ලියන් එළියට දාන්න නැහැ ඉන්ඩිවිජුවල් මම ගෙදර පන්ති කෙරෙවේ. දැන් මගෙන් ඉන්ඩිවිජුවල් කරනවා නම් මං කියනවා නෑ එහෙම නෙවෙයි. දැන් ඔයගලන්ට බාන මමම ඉඳගෙන වාට ඉන්ඩිවිජුවල් එකක් කරා නම් මේ කම්පිටිෂන් හැදෙන්නේ නැහැ. මේතන ගොඩාක් දක්ෂ ළමයි ඉන්නනේ. ඔයාලා අතර ඉන්නවා සුප්‍රීම් බ්‍රේක්ස් ඉන්න ළමයි ඉන්නවා මේ වගේ ආලුවෝ. සතුටු වෙන්න ඕනේ. හිතන්නේ මෙතන ඉන්නේ අයිලන්ඩ් ෆස්ට් එක්කෙනෙක් එක්ක අයිලන්ඩ් 1000 කියලා. ඔයාට වැඩි ළමයි 1000ක් ඉස්සරහින් අනිත් එක්කෙනා ඉන්නේ. හැබැයි ඒ පළවෙනියත් වෙනවා 1000ක් යනවා. ඒක නිසා ඩිස්කරේජ් වෙන්න එපා. ඔයාට වැඩි ගොඩාක් දක්ෂ යාළුවෙක් ඔයාලන් ඉන්නවා නම් ජෙලස් වෙන්න නැතුව ඩිස්කරේජ් වෙන්න නැතුව ඒක සතුටින් බාර ගන්න. ඒක පැත්තක්. එතකොට අර ක්‍රෂර්ස් හදාගෙන, ලව් ෆෙයාර්ස් හදාගෙන ඇයි ඔයාලගේ මේ පුංචි හිත් අවුල් කරගන්නේ? මම මේ හැමෝටම කියනවානේ මම මේ කියන්නේ කරන අයට මම ඒ පටන් ගන්නකොට කිව්වා ඉතින් ඔයගලන්ගේ අර ප්‍රොසෙස් වල ලව් ෆෙයාර්ස් වගේ තියෙනවා නම් මට ඒක නවත්තන්න බෑ. මං කිව්වට නවත්තන්නෙත් නැහැ. මට එක එක්සැම්පල් එකක් තියෙනවා. මම නොදැනුවත්ව කැමරාස් දාලා තියෙද්දි ඒ කියන්නේ ස්ටුඩන්ට්ස් හිතාගෙන ඉඳලා මම දන්නවා කියලා. අතින් අල්ලගෙන ගේට් එක ළඟට ඇවිල්ලා දාලා යනවලු අපේ රත්නපුරේ ගෙදර. එතකොට මම ක්ලාස් කරේ ගෙදරනේ. ඊට පස්සේ මොකක් හරි ප්‍රශ්නයක් වෙලා ඊට පස්සේ මට කියනවා "ඒ මැඩම් දන්නේ නැද්ද?" ඉතින් හැමදාම මේ ගෙදර අපේ ගේට් එකෙන් අසල දාලා ඉන්නේ අතින් අල්ලගෙන ඇවිල්ලා බොයිෆ්‍රෙන්ඩ් දාලා යනවා. ඊට පස්සේ මට නෙවෙයි යාළුවන්ට කිව්වා යාළුවෝ කියලා තිබුණා. මේ මට මොන දේ නැති වුණාද මම මගේ ලඝු ෆෙයා කෙනෙක් නැති කරගන්නේ නැහැ. එයා තමයි මගේ ලෝකේ උන්නම් කිය අර ඔයගලගේ චූටි ලෝකේ ඔයගලගේ බුද්ධි හීන කමට ඔයගලගේ මන්ද බුද්ධික කමටම බ්‍රේන් ඩෙවලොප්මන්ට් එක නැහැ නේ ඔයගලන්ට අවුරුදු 24ක් යනකම් බ්‍රේන් ඩෙවලොප්මන්ට් එකක් නැහැ. මහා ලොකු දේවල් වගේ නිකන් යාළු වෙනවා පුළුවන් දෙයක්ද අම්මා තාත්තගෙන් එකක් ඉන්නේ ඔයගොල්ලෝ අම්මා තාත්තගෙන් ගණකම කන ගමන් ඔයගලන්ට පුළුවන් ද වෙන ගර්ල් කෙනෙක්ට හරි බෝයි කෙනෙක්ට හරි සපෝට් කරන්න බෑනේ. ඉස්සෙල්ලා කොන්ද කෙලින් තියාගෙන තමන්ගේ දෙපාරේ නැගිටින්න ගන්නට ස්ටේටස් ඇති මිනිස්සෙක් වෙන්න. ඊට පස්සේ ඒව දිහා බලන්න ඔයගලන්ට යන්න මාර දුරක් තියෙනවා. ඒ දුර නැති කරගෙන ඔයගලන්ගේ චූටි හිත අස්සේ ඔය දේවල් එකතු කරගන්න එපා. ඔයගලන්ට එඩියුකේෂන් වලට ඔළුව දාන්න අමාරුයි. මම හැමදාම කියන කතාව තමයි මගේ සමහරක් යාළුවෝ දැන් මගේ මේ ඊයේ පෙරේදා බැච්මේට් කෙනෙක්ගේ අම්මා කෙනෙක් නැතුණා. කොහේ ගියාම අනේ අපිට ඔයා වගේ වෙන්න බැරිුණානි කියලා අනිවාර්යයෙන්ම 4-5 දිනක් හරි ඇඟේ එලිලා කියනවා. අනේ ආශා අපිට ඒ කාලේ අර හිම තිනවා මෙහෙම තිබුණා. සමහරක් අය ඇමරිකලා ඉන්නෙත් ඒ අයමයි. සමහරක් ලව් ෆෙයා සෝලෝ කාර්ය සමහරක් ඒවා ඒ ලෙවල් කාර්ය. කියලා එතකොට ඔළුව මාර විදිහට අහකට යනවානේ. ඒක තමයි ඩිස්ට්‍රැක්ෂන් ආවේ නැත්තම් අපිත් කරගන්නවා එහෙම කියලා. ඇත්තට මට වැඩි දක්ෂ මගේ යාළුවෝ ඉතින් කැම්පස් එකට හරියක්වත් තිබ්බේ නැහැ ඒගොල්ලෝ. යන්න ගොඩාක් දුර තියෙද්දි ඊට පස්සේ අන්තිමට මොකද උනේ කවුරු හරි මැරි කරලා ළමයි 3-4 දෙනෙක් හදාගෙන හැමදාම අර ඒ ජීවිතය තමයි. පාන්දර නැගිටිනවා, උයනවා, උදේට උයනවා, ගෙවල් අතු ගන්නවා, ළමයින්ගේ රෙදි හොදනවා, හස්බන්ඩ්ගේ රෙදි හොදනවා, වොෂින් මැෂින් තමයි දාන්නේ. ඒකට කරන්න එපා නේද? ඊට පස්සේ ඔය ටික ගෙට ගන්නවා, වේලනවා, අයන් කරනවා, දවල්ට පත්තු වෙනවා, ඒ බලන් ටික හොදනවා, රෙදි ටික නවනවා, අල්මාරියට දානවා, අයන් කරන ඕන ටික අයන් කරනවා, රැට කන්න ඕනේ කැම්ප් ටික ලෑස්ති කර ගන්නවා. ඊට පස්සේ ඊළඟ දවසේ දෙපා පාන්දර නැගිටලා උයනවා. නේද? ඒ අතර තියෙන ඉතුරු ළමයින්ගේ වැඩ ටිකයි ඔය ඔක්කොම මැද්දේ ඒගොල්ලන් ජීවිතයක් ගන්න. එහෙම ඔයාලා එහෙම වෙන්නත් එපා. එහෙම කරන ඔයගලන්ගේ අම්මෙක් හරි තාත්තෙක් හරි ඉන්නවනම් සහ තව තාත්තලා ගෙනත් ඔයගොල්ලෝ ආදරෙන් හිටන් පුරුදු වෙන්න ඕනි. තාත්තා කෙනෙක්ට හරියට මානසිකලා දැන් මගේ මේ සෙට් එකේ කිප දෙනෙක්ගේ තාත්තා නැති වුණානේ. ඊටකොට ඒ අම්මලා අර අඬන දුක කියන්නේ අනේ මැඩම් මෙයා තමයි පාන්දර ළමයි හැරවන්නේ. කිරියක හදලා දෙන්නේ තාත්තා. ඇඳුම් අයන් කරලා දෙන්නේ තාත්තා. ඒතර බත් එක අම්මා උයනවා. ඊට පස්සේ අම්මාත් ඔෆිස් යනවා නම් අම්මලා ඇස්සෙනකන් තාත්තා තමයි ලන්ච් පැකට්ස් ටික දාලා ඒවා භාජන වලට දාලා ඔය ටික කරලා දෙන්නේ තාත්තා. ඒතකොට වැඩ භාගයක් තාත්තත් කරලා. ඉතින් ඕගොල්ලන්ට ගුණවන්ත වෙලා ගුණගරුක වෙලා ආදෙන් දැන් ඕගොල්ලන් හිතෙන් අහන්නකො කවුරු හරි කියනවා නම් දුවෙක් හරි පුතෙක් හරි කමන්නේ. පුතේ මට අමාරුයි මේ වැඩේ කරලා දෙන්න කියලා ෆෝල්ඩින් එකක් දාලා දෙන්න. එළවලු චුට්ටක් සුද්ධ කරලා දෙන්න කියද්දි අනේ මට බෑ මට වැඩි කියලා ඕගොල්ලෝ කවුරු හරි කියනවා. ඕගොල්ලන් හිතෙන් අහන්න ඕගොල්ලන්ට ඉච්චර වැඩද කියලා. නැහැ. එතන ඕගොල්ලන් කරන්නේ රැවටීම. ඔයගලන්ට උතරක් නිකන් ඉන්න වෙලාව තියෙනවා. හැබැයි අම්මට තාත්තට උදව්වක් කරන්න කියපුවම අනේ මට පාඩම් කරන්න තියෙනවා, ගණන් හදන්න තියෙනවා, හෝම්වර්ක් තියෙනවා 500ක්. අයිනා නේද? 500ක් හේතු කියනවා නේද? එහෙම වෙන්න එපා. ආදරණීය දරුවෙක් වෙන්න. අම්මට තාත්තට හරිය ආදරෙන් සලකන්නේ. දැන් ඒ නැති වෙච්ච දුව නැති වෙච්ච අම්මා කෙනෙක් මට අදවත් අම්ම නැතු බෑ. මම මැරි කරලා මම ඉන්ඩිපෙන්ඩන්ට් මගේ වර්ල්ඩ් එක වෙනස්. ඒත් අර මම මදර් ෆිගර් එක මට මාර එනර්ජි එකක් මගේ ලයිෆ් එකට මොන හරි වෙච්ච ගමන් අර අම්මා මතක් වෙලා අම්මට කෝල් කරලා අයිඩියාස් ටික අරගෙන එහෙම ස්ට්‍රේට් කනෙක්ෂන් එකක් තියෙනවා. ඔයාලට නම් හිතා ගන්න බෑ. ඔයගොල්ලන්ගේ අතරපයට හැමදේම තම අම්මනේ. දැන් එහෙම වෙලාවක ඒ අම්මා කෙනෙක් නැතුනහම ඒ ළමයාට ඉතුරු මුළු ජීවිත කාලෙම ඉතින් ඒක කරගෙන යන්න වෙනවා. හිතන්නකෝ ඒ ගෙදර තව නැහැ කියලා එයාට සහෝදරියක්වත්. ඒතකොට ඒ ගෙදර අම්මා වගේ වෙන්න වෙන්නේ අර ඒ පුංචි ළමයාට. ඔයගොල්ලන්ට වැඩි අවුරුද්දක්නේ වැඩිමල් ඒ පුංචි ළමයාට. ඉතින් හැබැයි මම දන්නේ නැහැ ඒ ළමයා කියන්නේ අම්මට උදව් කරලාද නැද්ද කියලා. ඉතින් දෙමාපියන්ට ආදරෙන් සලකන්න සහ ණය ගෙවන හොඳම විදිය තමයි මේ එක්සෑම් එකෙන් මැක්සිමම් රිසල්ට්ස් දාන්න. එතකොට ඒ දෙමාපියෝ දැන් මට වැඩි ගොඩක් වැඩිම දෙමාපියෝ ඇවිල්ලා මට වදිනවා. අනේ මැඩම් මට ඒ කියන්නේ සමහර මේ පේරන්ට්ස්ලා ඉන්නවා ඒගොල්ලන්ගේ මුළු පරම්පරාවෙම පළවෙනි ඉංජිනේර්, පළවෙනි ડોක්ටර්. එතකොට ඒ මුළු පරම්පරාවකම මේ රිස්පෙක්ට් එක අරන් දෙන්නේ ඒ ළමයා. ඒ ළමයා ඔය ආදර. ඔයාලට ඒක කරන්න පුළුවන්ද? ආදරණීය වෙන. තව චුට්ටක් මට කියන්න ඕන කියලා හිතුණා. අම්මගේ අම්මා හොඳයි. මාර හොඳයි. මාර ආදරණීයයි. චූටි කන්දරව බලාගෙන තිනවා, උදව් කරලා තිනවා. හරිම අහිංසකයි, හරිම හොඳයි ඒ ආච්චි අම්මා. හැබැයි තාත්තගේ අම්මා හරිම නරකයි. හරි නපුරුයි. අපිට චූටි කන්දර වෙනස්කම් කරලා දෙනවා. නේද? ඉතින් තාත්තගේ අම්මා එච්චර නරකයි නම් ඒ තාත්තා කොච්චර නරක වෙන්න ඕනිද? නේද? තාත්තගේ අම්මා නරක වෙලා තාත්තෙක් හොඳ වෙන්න බෑනේ. ඒ කියන්නේ ඔයගලන්ට ඉන්නේ නරක තාත්තලානේ. නේද? අම්මලා එහෙම කියනවා නම් අම්මලාගේ ඒ තියෙන ඇටිටියුඩ් එක ඔයගොල්ලෝ වෙනස් කරන්න. ඔයගොල්ලොත් ඒක ෆියුචර් එකට ගෙනියන්න එපා. අම්මා හොඳයි නැන්දම්ම නරකයි කියන්න එපා කියලා මම මේ කියා දෙන්නේ. මගේ ෆැමිලි එකෙත් නෑ ඒක. සර්ගේ ෆැමිලි එකෙත් නෑ. සර්ගේ අම්මා මාරම මේ රෝ මොඩල් එකක් මදර් ෆිගර් එකක්. මගේ අම්මත් එහෙමයි. අපිටත් එකයි, අප්පගේ මල්ලිගේ වයිෆ්ටත් එකයි. තෑගි ගත්තොත් ඔක්කොටම එකට, බැන්නොත් ඔක්කොටම එකට, කන්න කෑම ගෙනාවොත් ඔක්කොටම එකට. එහෙම මේන්ටේන් වෙන්න පුරුදු වෙන්න. අර ඔයගොල්ලන්ගේ චූටි කාලේ ඉඳලා මම දන්නේ මොන ඇටිටියුඩ් එකක්ද කියලා. ඒ කියන්නේ මේකත් මට මේ මගේ ෆැමිලි අස්සෙන් මේ යාළුවන්ගේ අස්සෙන් වෙන ඒවා. අර දැන් මගේ යාළුවෙක් නැති කාලේ ඉතින් මට අල්ලපු ගෙදර කට්ටිය කිව්වා අනේ මේ අම්මගේ ළඟ ඉන්නේ ළමයි වරුවයි මුළු නිවාඩු කාලෙම ගිහිල්ලා ඉන්නේ මේ අම්මගේ පැත්තේ ආච්චියක් නැහැ ගෙදර කියලා. ඒතර තාත්තගේ අම්මා ළඟ වරුවක් ඉඳලා අම්මගේ අම්මා ළඟ නිවාඩු කාලයක් ඉන්නකොට ඉතින් ඒ ළමයින්ගේ මන් දන්නේ නැහැ මොන ඇටිටියුඩ්ස්ද කියලා. එහෙම වෙන්න එපා. අම්මගේ අම්මටත් ආදරේ වෙන්න තාත්තගේ අම්මටත් ආදරේ වෙන්න ඔයගොල්ලන්ගේ මල්ලියෙක් හරි අයියෙක් හරි ඉන්නවා නම් චුට්ටක් හිතන්නේ මල්ලි හරි අයියට හරි අම්මා හරි තාත්තා හරි සලකන විදියට. ඔයාගේ තාත්තගේ අම්මා ඒ තාත්තට එහෙම තමයි සලකලා තියෙන්නේ. එච්චර ආදරණීය කරක්ට් එකකට ඔයගොල්ලෝ ආදරේ නොකරනවා නම් ඔයගොල්ලෝ හරි වැරදි. පේරන්ට්ස්ලාගේ වැරදි අයිඩියාස් තියෙනවා නම් ඔයගොල්ලෝ වෙනස් කරන්න. අද දැන් ගෙදර යනකම් මං හිතන්න ඕගොල්ලෝ ආදරණීය දයාවන්ත ගුණවන්ත හොඳ දරුවෝද කියලා. හරිසනේ ගිහින් යන්නේ උත්සාහ නැහැ.